Welcome back, friends. Today we will learn the new topic, that is equilibrium state and characteristics of the equilibrium state. So equilibrium state means a stage where reversible reaction do not show any noticeable change in the measurable properties like pressure, concentration, density or color. This stage is known as equilibrium. We call it as the reaction is at equilibrium. If we talk in terms of physical change, let us take an example of a container. This is a tank. Water in the tank. There are two taps in the tank. One thing, both the taps are closed. Let's say this is the level of the tank. Water is filled up to this. So level, is there any change in the water level? No, because both the taps are closed. So level of the water in the tank remains same. This type of equilibrium is known as static equilibrium. No change in the water level, no change in the concentration, no change in any properties, because there is no change taking place at all. But if we open both the taps simultaneously with same volume water coming in, going out, is there any change in the level? No, because water coming in, volume of the water coming in is equal to volume of the water going out. This type of equilibrium is known as dynamic equilibrium. Both the taps are on, but level of the water remains same because volume of the water coming in is equal to volume of the water going out. Such type of equilibrium takes place in the chemical reactions in which rate of forward reaction is equal to rate of backward reaction. So the number of moles of what A and B converted into C and D is equal to number of A and B formed from C and D. And in this way, concentration of A, B, C and D is constant at a particular instant of time, and that stage is known as equilibrium state. And what are the characteristics? First characteristic of equilibrium state is equilibrium state is always achieved in a closed vessel. Closed vessel means that reactant or products present in the mixture are not allowed to go out. For example, if we deal with gaseous moles and reaction is like calcium carbonate solid, calcium oxide solid, carbon dioxide gas. If vessel is open, what happened? Carbon dioxide goes out, it escapes out. Therefore, equilibrium can never come back. But if vessel is closed, calcium oxide as well as carbon dioxide both are in the same container, they can combine, and that's why reaction become reversible. That means first condition should be that container vessel should be closed. Equilibrium state can be achieved only if reversible reaction is carried out in a closed vessel. Condition number 2. Chemical equilibrium at a given temperature is characterized by constancy in the properties like pressure, concentration, density or color. And next, chemical equilibrium can be achieved from either side. It can be achieved from either side. Equilibrium can be achieved from forward or backward. Like reactant decreases, product increases with time, but it can be achieved from either side. That means if we have a reaction like reactant to product, then we start with reactant, then reactant decreases, product increases. But if we start with product, then product decreases, reactant increases. At equilibrium, concentration of reactant as well as product are same. That means equilibrium can be achieved from either side, because equilibrium state is independent of the initial concentrations. Whatever may be the initial concentration, it has nothing to do with that. It depends on the concentration of the reactants and products at equilibrium, and that value is fixed. Either we start from reactant or product. Now, fourth point, role of catalyst. Catalyst does not change the value of equilibrium constant. Value of equilibrium constant is same in the presence or absence of catalyst, but equilibrium can be achieved in lesser time if we use a catalyst, because catalyst increases the rate of reaction, rate of forward reaction as well as rate of backward reaction. So when we draw plot time, rate of forward reaction increases, rate of backward reaction also increases. That's why in the absence of catalyst, it takes more time to become equal, but in the presence of catalyst, it can be achieved in lesser time. This is in the absence of catalyst. And when we add the catalyst, rate of forward as well as backward, both reaction increases, and that's why in the presence of catalyst, attainment of equilibrium takes lesser time. Means it fastens the rate of attainment of equilibrium. So these are the characteristics of equilibrium state. Thank you very much for watching this video. Do like, subscribe and share my channel for the benefit of all. God bless you all. Happy learning. Welcome back, friends. Today we will learn about the factors affecting equilibrium constant. So let us take a reaction in which A is converted into B and its equilibrium constant is K1. K1 is equal to B by A, product concentration divided by reactant concentration, and this is equilibrium constant of this reaction. Now if we reciprocate this reaction. If we reverse this reaction, A to B changes into B to A. Now what is equilibrium constant? Let us say it is K2, and this K2 becomes A divided by B. So this is just reverse of this reciprocal. That means K2 is equal to 1 upon K1. It means if forward reaction has rate constant K1, then backward reaction has reciprocal of K1. Backward reaction B to A, then equilibrium constant is equal to reciprocal of forward rate constant. K2 is equal to 1 upon K1. Third, if we multiply this equation with any number, say 2, then equilibrium constant is B raised to power 2, A raised to power 2, that is B upon A whole raised to power 2. That means equilibrium constant becomes K1 raised to power 2. That means if we multiply the equation with any number, then equilibrium constant becomes equal to the power of equilibrium constant of the equation to which we multiply the number. If we divide it by any number, say 2 divided by 2, 1 by 2 A, 1 by 2 B. So equilibrium constant becomes B raised to power half, A raised to power half, that is B upon A whole raised to power half. So it becomes K1 raised to power half. Then if we have another equation, if C to D equilibrium constant is K5, and you know A to B equilibrium constant is K1, and we add these equations, then A plus C, B plus D. We add these equations, so equilibrium constant becomes equal to B into D divided by A into C. So B upon A is K1, D upon C K5. That means if we add two equations, their equilibrium constants are multiplied. And if we subtract two equations, C to D is K5 and A to B K1, and we subtract, that means B plus C to A plus D. That means it is not C plus A, B plus D as the previous one. It is C plus B. That means this equation is subtracted from it. So it becomes K5 divided by K1. If we add the equations, equilibrium constants are multiplied. If we subtract the equations, equilibrium constants are divided. Okay? These are the rules or factors affecting the equilibrium constant. Thank you very much for watching this video. Do like, subscribe and share my channel for the benefit of all. God bless you all. Happy learning. Welcome back, friends. Today we will learn homogeneous and heterogeneous equilibrium reactions. So heterogeneous reactions. So the reversible reaction in which more than one phase is present are known as heterogeneous reactions. For example, calcium carbonate, which is solid. So when calcium carbonate decomposes on heating, we get calcium oxide solid and carbon dioxide gas. It is not a homogeneous mixture. So this type of reaction is studied under the heading of heterogeneous equilibrium or heterogeneous reaction. Another example, for example, iron. When steam is passed through it, we get Fe3O4 solid plus H2 gas. This is another example of heterogeneous equilibrium. See, iron is solid, then H2O is gas. Homogeneous equilibrium or homogeneous reaction. Homogeneous equilibrium, these are the reversible reactions in which only one phase is present. For example, H2 gas plus I2 gas to give 2HI gas. So gases, they can form homogeneous mixture. Another example is like we have ethyl acetate. This is again an example of homogeneous equilibrium because all are soluble in water. So this is again an example of homogeneous equilibrium. So what do you mean by homogeneous and heterogeneous equilibrium? Homogeneous means only one phase is present. It is not state. Okay. Remember, it is phase. Phase means uniform mixture. Like say, these are different liquids, but when they mix together in water, they form a homogeneous mixture, and that's why it is known as homogeneous reaction, because only one phase is formed. But when we have solids, it is written as solid. That means it is not mixed together. Like if we take sugar and salt without water, then that is one type of heterogeneous mixture. It is not a reaction. There is no reaction taking place. But as an example, if we take two solids, then they always form a heterogeneous mixture. Same is the case here. If we have gases, they form homogeneous mixture. There is only one phase. If we take liquids, soluble liquids, they are soluble in water, then again it becomes homogeneous reaction. But as we have learned, calcium carbonate solid, that give calcium oxide solid and carbon dioxide gas. So that type of reaction is a heterogeneous equilibrium because there are more than one phase in the reaction mixture. What is the relation between Kp and Kc? This is the question from chemical equilibrium. Equilibrium chapter दोस्तों is not difficult chapter. Please keep in mind, it is very easy chapter. Like this relation, sure one question should be there from this relation. So first we derive this relation, then we do some numericals related to the same. So if question is, what is the relation between Kp and Kc? So you start with, consider a reaction. This reaction. In this reaction, how do we read it? Small a moles of reactant capital A reacts with small b moles of reactant capital B to give small c moles of product C and small d moles of product D. This A, B, C and D, these are stoichiometric coefficients of reactants and products. Now, to write Kc, what is Kc first? Kc is equilibrium constant in terms of concentration. And you know, concentration is written like this. So, to get Kc, concentration of product of the concentration of products raised to the power their stoichiometric coefficients divided by product of the concentration of reactants raised to power their stoichiometric coefficients. This square bracket C, this is molar concentration of product C. Same is the case with D, molar concentration of product D. What is A? This is molar concentration of reactant A. And what is B? You can say now. What is B? This is molar concentration of, yes, molar concentration of reactant B. Good. In this way, now Kp. What is Kp? Kp is, like Kc is equilibrium constant in terms of concentration. Kp, equilibrium constant in terms of pressure. So, again this is pressure of C raised to power C, pressure of D raised to power D, pressure of A raised to power A, pressure of B raised to power B. Done? What is PA, PB, PC and PD? These are partial pressures of reactants A and B and products C and D. PA, PB. These are partial pressures of reactant A and B respectively. And same is the case with PC and PD. PC and PD, partial pressures of products C and D respectively. Now you know, according to ideal gas equation. What is ideal gas equation? You have studied in states of matter, even in first chapter. You know, PV equal to nRT. So now what is P? P is equal to N by V RT. And what is N by V? Number of moles per unit volume. And this number of moles per unit volume is known as molarity. So in this way, P is equal to molar concentration into RT. So likewise, what is PA? Concentration of A, RT. What is PB? Concentration of B, RT. What is PC? Bolo bhai. PC is, yes, concentration of C, RT. What is PD? PD, concentration of D, RT. So in this way, we get PA, PB, PC, PD. Now, we replace PA, PB, PC and PD by these concentration terms. So Kp is equal to PC is replaced by PC RT raised to power C, DRT raised to power D divided by ART raised to power A and BRT raised to power B. So in this way, just separate concentration terms. These are concentration terms: C raised to power C, D raised to power D, A raised to power A, B raised to power B. What is left? RT, RT raised to power C, RT raised to power D. If base are same, then powers are added, and if they are divided, then it is subtracted. So RT in numerator, RT raised to power C plus D, and here RT raised to power A plus B. So tell me, what is this? This whole thing is, bolo, this whole thing is Kc. So Kc, now RT raised to power, yes, RT raised to power C plus D minus A plus B. What is C plus D now? Tell me, what is C plus D? C plus D is number of moles of product. And what is A plus B? Number of moles of reactant. In this way, what is delta Ng? This number of moles of product minus number of moles of reactant is called delta Ng, that is C plus D minus A plus B. That means this C plus D minus A plus B is replaced by delta Ng. And what is delta Ng? Change in gaseous moles of reactant and product. So in this way, we get Kp equal to Kc RT raised to power delta Ng. So this is your final relation. If question is there, what is the relation between Kp and Kc, then you end up your expression, your derivation up to this point. And to explore further, you can go like, if delta Ng is 0, then what is the relation between Kp and Kc? Delta Ng is 0, so that implies Kp is equal to Kc. If delta Ng is greater than 0, then what is Kp? Is it greater than Kc or less than Kc? Kp is greater than Kc, because something is multiplied by Kc to get Kp. If delta Ng is less than 0, then Kp is less than Kc. Right? So, if question is H2 gas plus I2 gas to give 2HI gas, what is the relation between Kp and Kc? So to get a relation between Kp and Kc, just calculate delta Ng. So can you tell me what is delta Ng in this reaction? Yes, calculate. So delta Ng is number of moles of product minus number of moles of reactant. So product, there are two gaseous moles, and reactant 1 plus 1 again 2. So it is 0. That implies Kp is equal to Kc for this reaction. Okay, if we have reaction like this, calcium carbonate solid to give calcium oxide solid, CO2 gas. Yes, what is delta Ng for this reaction? Delta Ng, yes, bolo. It is 1 minus 0, that is 1. That implies Kp is greater than Kc. Because on product side, gaseous moles is only 1. That is CO2 gas. This is solid. On reactant side, calcium carbonate is solid. That means it is not counted because we count only gaseous moles. Then C solid plus O2 gas to give 2CO gas. Yes. What is delta Ng? Again, delta Ng is 2 minus 1. Product side 2 gaseous moles, reactant side 1. So 1. That means again Kp is greater than Kc. Can you give any example in which Kp is less than Kc? Think about it. So this can be like this reaction, N2 gas plus 3H2 gas to 2NH3 gas. Yes, what is delta Ng for this reaction? Product side 2 gaseous moles, reactant side 3 plus 1, that is 4. That means minus 2. So Kp is less than Kc. That's all for this relation between Kp and Kc. Thank you very much for watching this video. Do like, share. Explain why pure solids and pure liquids can be ignored while writing the value of the equilibrium constant. For example, we have this reaction. In this reaction, while writing the expression for Kc, we take into account concentration of NO2 raised to power 4 and concentration of O2 raised to power 1. We have ignored copper oxide as well as copper nitrate. Why is it so? Because while writing Kc, we do not write pure solids and pure liquids concentration. Why is it so? Because this concentration, this is actually molar concentration, molarity, and that is equal to number of moles divided by volume, and number of moles is proportional to mass per unit volume, and that is density. And density is an intensive property. So for pure solids and pure liquid, density remains same. If volume decreases, at the same time mass decreases. So mass per unit volume remains same for pure solids and pure liquids. So their concentration remains same, remains constant. That's why we do not write concentration of pure solid and pure liquid. Let us take one more example. So see, in this case, ethyl acetate, acetic acid and ethanol, they are aqueous. Water is pure liquid. So pure liquid is ignored while writing the expression for Kc. Expression for Kc is like this. We ignore pure liquid because in case of gaseous species or aqueous species, mass vary in a given volume. If mass varies, obviously their moles vary, and if moles vary, moles per unit volume increases or decreases, and that's why they should appear while writing the expression for the value of Kc. Let us discuss units of equilibrium constant. So you know, for a reaction, equilibrium constant is equal to this concentration raised per C, concentration raised to power D, concentration raised to power A, concentration raised to power P. That means concentration raised to power C plus D minus A plus D. So we can say unit of Kc is equal to mole per liter raised to power delta N. Change in number of moles. So delta N equal to number of moles of product minus number of moles of reactant. For example, if we have a reaction N2 plus 3H2 gas to give 2NH3 gas, what is the units of Kc? So unit of Kc is mole per liter raised to power 2 minus some of the reactants, 3 plus 1, 4, 2 minus 4. That means is mole per liter raised to power minus 2. Means mole minus 2 liter raised to power 2. If we have a reaction like H2 gas plus I2 gas to give 2HI gas, Kc has no unit because in this case mole per liter raised to power delta N, and delta N is equal to 2, and this is also 2, so 2 minus 2, 0. That means no unit of Kc if delta N is 0, and unit of Kp, that is equal to unit of pressure raised to power delta Ng. Unit of pressure like bar raised to power delta Ng, atmosphere raised to power delta Ng, and again if number of moles of product is equal to number of moles of reactant, then that has no unit.
Hello everyone. So today we are going to discuss one of the application of equilibrium constant. Really it is a very important property of equilibrium constant, that is predicting the extent of reaction. You know, when we write any chemical reaction like this particular reaction, the equilibrium constant is product of the concentration of the products divided by product of the concentrations of the reactants. That means equilibrium constant is actually the ratio of the concentrations of the products and reactant at equilibrium. So magnitude of the equilibrium constant, that gives us an idea of the relative amount of reactants and products present at equilibrium. You know, if product is large, Kc is obviously large. If reactant is large at equilibrium, value of Kc is equilibrium constant is low, and if both are present in significant amount, then value of Kc is intermediate. So we have three cases. So first case is when there is a large value of the equilibrium constant. If value of the equilibrium constant is very large, that means amount of the product is much larger than that of the reactants at equilibrium. So that means forward reaction is favored. Product is more, that means reaction is favored in the forward direction. And large value we take into account more than 10 raised per 3. Any value of Kc more than 10 raised per 3 is taken as large value, and we say that this reaction is favored in the forward direction. For example, we have H2 plus Br2 to 2HBr, H2 plus Cl2 to 2HCl. See the value of Kc, that is far greater than 10 raised per 3 even, 10 per 18, 10 per 31. That means products are much larger than the reactants at equilibrium. Now, if we have an intermediate value of equilibrium constant, that is in between 10 raised per minus 3 to 10 raised per 3, it shows that reactant as well as product both are present in significant amount. Their amount is comparable. For example, we have these two reactions in which, see, the value of equilibrium constant is, first case it is 138 and in the second case it is 57. And one thing you note, that every time I have mentioned the temperature. So yeah, keep in mind that equilibrium constant is constant at a constant temperature. If we vary the temperature, value of the equilibrium constant changes. That's why while writing the value of equilibrium constant, we have to mention the temperature, right? Okay. Now, third case is when value of equilibrium constant is low, that is less than 10 raised per minus 3. So obviously this is the case where amount of the reactant is much larger than the amount of the product, or we can say amount of the product is very, very less, or sometimes it is almost negligible. In this case, backward reaction is favored. So the example is N2 plus O2 to give 2NO. What is the value of Kc? It is 4.8 into 10 raised per minus 21 at 298 Kelvin. That means NO is present in very little amount. In the mixture, major contribution is from N2 and O2. N2 and O2 are in a very large amount, and very small amount of NO is present at equilibrium. So this whole three cases we can generalize in this case, that if value of Kc is, this is the value of Kc, the value of Kc is 10 raised per minus 3 or less than that, that means the value of Kc is taken as very small, and therefore if it is negligible, reaction proceeds hardly, it cannot take place at all, or we can say backward reaction is favored. Okay, if value of Kc is in between 10 raised per minus 3 to 10 raised per 3, that means both reactants and products are present in significant amount at equilibrium. And third is when value of Kc is greater than 10 raised per 3, or it is extremely large. In that case, reaction proceeds almost to completion. So while studying equilibrium, we will take into account this part, because these are the reactions where we have to look how much reactant and product is formed. If it is very, very small or negligible, that means there is no need to study it. If it is very large, that means reaction is almost to completion. Product is much larger than reactant, there is no need to study. So major portion where we have to apply laws of equilibrium and we have to study the equilibrium if the value of Kc is in between 10 raised per minus 3 to 10 raised per 3. So that's all about today's session, where I have taken into account that how much extent of reaction takes place, that you can know if you know the value of Kc. Thank you so much for watching this video. Do like, subscribe and share my channel. God bless you all. Happy learning. Jai Hind, Jai Bharat.
Welcome back, friends. Today we will learn relation between reaction quotient and equilibrium constant. Reaction quotient is also known as mass action ratio. So what do you mean by reaction quotient? Actually, if we have a reaction like A plus B to give C plus D, Q is equal to C into D divided by A into B, and this is called QC, reaction quotient in terms of concentration. And if in terms of partial pressure, it is called QP. Now this QC and QP, it is known as reaction quotient, and it is used to predict whether the reaction is at equilibrium or not. Now first, what is this QC? Actually, if we plot a graph between concentration versus time, then A and B, if we start with reactants, it is like this, and C and D. Now at any instant of time, the ratio of the concentration of products to the reactants is known as reaction quotient. And at this time concentrations are constant, this is known as equilibrium, and the same ratio of product to the reactant at equilibrium is known as equilibrium constant. If we start with product, then here you can see that equilibrium can be established from forward side as well as from backward side. We can start with reactants as well as products. So you can see equilibrium can be achieved from right side or from left side. We can start with reactant as well as product. So now different cases are there. This is the graphical representation. If QC is equal to KC, this one, at this point of time, a rate of forward reaction is equal to a rate of backward reaction. So reaction is already at equilibrium. Reaction is at equilibrium. Case 2, if QC is less than Kc. This is the case. Kc remains same. Value of Kc remains same, but QC can be greater than Kc or less than Kc or equal to Kc. So reaction quotient, if it is less than Kc, that means the rate of forward reaction is greater than rate of backward reaction, because QC less than Kc means still the forward reaction is faster than backward, so that reaction can reach the equilibrium concentrations to reach this point, because ultimately at the end of the reaction QC should be equal to Kc, that is equilibrium. Means ultimate aim of QC is to reach Kc. That means forward reaction is faster than backward, or we can say reaction favors forward reaction. Both reaction takes place, but speed of forward reaction is more than backward reaction. Case 3. If QC is greater than Kc, it means now rate of backward reaction is greater than forward reaction, because now product is more than that should be at equilibrium. So backward reaction is greater than forward reaction. So if backward reaction is faster than forward reaction, that means backward reaction is favored. In this case, forward reaction is favored. In this case, backward reaction is favored. It goes down, it goes up. It remains same. That means no reaction is favored. Forward rate, backward rate is same. In this case, forward rate is greater than backward rate. In this case, forward rate is less than backward rate. Speed of the forward reaction is greater than backward reaction if QC is less than Kc. Speed of forward reaction is less than backward reaction if QC is greater than Kc. So these are the cases: QC less than Kc, QC greater than Kc. So this is all about the relation between reaction quotient and equilibrium constant. Thank you very much for watching this video. Do like, subscribe and share my channel for the benefit of all. God bless you all. Happy learning. Thank you. Chatellier's principle. This principle was given by Chatelier and Brown in 1884. According to this principle, if a system under equilibrium is subjected to a change, if we change the concentration of reactant or product, or if we change the temperature, if we change the pressure, or if we add some inert gas, then equilibrium shifts itself in such a way as to undo or neutralize the effect of the change. The change should be neutralized. For example, if we talk about concentration, let us discuss first effect of concentration. Reactant to product. Now let us take this reaction is in equilibrium. Kc equal to product over reactant, and that is equal to Qc because reaction is at equilibrium. Now if we add reactant, as we add the reactant, additional reactant is added, equilibrium is disturbed. What it means? Now reactant is increased, so Qc is less than Kc. Qc becomes less than Kc. We have discussed reaction quotient. If reactant is added, equilibrium tries to undo the effect, so reactant should decrease. So when Qc is less than Kc, that means forward rate is greater than backward rate. At equilibrium, forward rate is equal to backward rate, but now forward reaction is greater than backward reaction. That means now forward reaction is faster than the backward, so forward reaction is favored. So if we add product, now we add product in the already established equilibrium. When we add the product, what will happen? Product increases, that means Qc becomes greater than Kc, and as product increases, so backward rate is faster than forward reaction. That means backward reaction is favored by the reaction. That means if we increase the reactant, forward reaction is favored. If we increase the product, backward reaction is favored. And at the same time, if we add reactant or remove product, in both the cases Qc becomes less than Kc and forward reaction is greater than backward reaction. Same, if we increase the product or decrease the reactant, then Qc become greater than Kc. So if product is added or reactant is removed, in both the cases Qc is greater than Kc and backward reaction is favored. So this is about the effect of concentration. Second is effect of pressure. If we deal with only solids and liquids, then there is no effect of pressure. If a reaction involves only pure solids or pure liquids, then there is no effect of pressure. But if a reaction has gaseous moles, then there is a significant effect of pressure. Let us discuss three cases. So let us study the effect of pressure on these three reactions. First, what's the basic of the pressure effect? If we increase the pressure, then that side of the reaction is favored where pressure decreases. And you know, pressure is proportional to number of gaseous moles and inversely proportional to volume. So increase in pressure favors that side of the reaction where gaseous moles, where number of gaseous moles are less. That means the side where volume of gaseous moles decreases. If we decrease the pressure, reaction favors that side where gaseous moles are more. Now come to this. In this case, you know, delta Mg is 0 because number of moles of product is equal to 2 and number of moles of reactant is also equal to 2, and you know delta Mg is equal to gaseous moles of product minus gaseous moles of reactant, and that should be equal to 0. That means no effect of pressure. Such reaction is not affected by change in pressure. Come to the second. On product side, number of gaseous moles are 2. On reactant side, number of gaseous moles are 3 plus 1, 4. So delta Ng is equal to product minus reactant minus 2. That means decrease in gaseous moles. So decrease in gaseous moles favored by increase in pressure. So increase in pressure favors this reaction. Means if delta Ng is negative, less than 0, such reaction is favored by increase in pressure. Third one, number of gaseous moles of product is equal to 2. Number of gaseous moles of reactant is equal to 1. In this case, delta Ng is equal to 2 minus 1 means 1. Means number of gaseous moles increases. So such reaction is favored by decrease in pressure. Decrease in pressure favors that side of the reaction where gaseous moles are more, and increase in pressure favor that side of the reaction where gaseous moles are less. In first case, gaseous moles are same on both sides, that's why there is no effect of pressure. And if there is a reaction which involves only solids and liquids, no effect of pressure. No. Third one is effect of temperature. When we increase the temperature, temperature is increased because heat content increases. As heat content increases, equilibrium shifts to that side which absorb the heat. Means which type of reaction takes place? Which absorb the heat. And heat absorption takes place in endothermic reaction. That means endothermic reactions are favored. And if we decrease the temperature, means we decrease the heat content. So reaction or equilibrium is established by favoring the reaction which increases the heat content, which release the heat. So heat is released by exothermic reactions. So exothermic reactions are favored on decreasing temperature, and endothermic reactions are favored by increasing temperature. In the reaction where delta H is positive are favored by increase in temperature, and reaction where delta H is negative are favored by decrease in temperature. And if we have a reaction which has delta H equal to 0, neither heat absorbed nor evolved, in such a reaction there is no effect of temperature. So temperature effect is observed in those reactions which involves absorption of heat or evolution of heat. Heat is either absorbed or evolved. Only then temperature affects the reaction. And increase in temperature favors endothermic reactions. Decrease in temperature favors exothermic reactions. And if there is no absorption or evolution of heat, means for the reaction where delta H is 0, there is no effect. fourth is effect of addition of inert gas. First, at constant volume. At constant volume, when we add inert gas at constant volume, number of moles of reactant and product remain same. Volume is again constant. This is inert gas, no contribution to reactant or product. So number of moles of reactant per unit volume, number of moles of product per unit volume remain same. That means concentration of product, concentration of reactant remain same. So QC remains equal to KC. That's why no effect of adding inert gas at constant volume. Now at constant pressure, if we add inert gas at constant pressure, remember this is very important. When we add inert gas, gaseous content increases. There is no effect on number of moles of reactant or product, but gaseous content increases. And pressure is proportional to number of moles. Initially, pressure increases, but we have to keep it constant. To keep it constant, to keep pressure constant, we have to increase volume. If we increase the volume, then number of moles of reactant per unit volume, number of moles of product per unit volume decreases. That means concentration decreases. As concentration decreases, so reaction favor that side of the reaction where gaseous moles are more. So keep in mind, at constant volume there is no effect of adding inert gas, and at constant pressure, when we add inert gas, reaction favor that side where gaseous moles are more. If we add inert gas, in first case, if we add inert gas at constant pressure, equilibrium shifts towards that side where gaseous moles are more. Means it moves to the right on adding inert gas at constant pressure. That means decomposition of PCl5 increases. What about second reaction? If we add inert gas at constant pressure, equilibrium shifts to the left, backward. That means formation of SO3 decreases on adding inert gas at constant pressure. In third case, as there is no change in gaseous moles on both sides, gaseous moles are equal, so there is no effect of adding inert gas even at constant pressure. Effect of catalyst. We have already discussed effect of catalyst. In a reversible reaction, catalyst increases the rate of forward reaction as well as backward reaction. It increases the rate of forward reaction as well as backward reaction, and therefore it fastens the rate of attainment of equilibrium, but it cannot affect concentration of reactant or product. So it has no effect on equilibrium. Catalyst has no effect on equilibrium, it only decreases the time of attainment of equilibrium. Means rate of attainment of equilibrium becomes fast. Only lessens it decreases the time taken to reach the equilibrium. That's all about this principle. It was given by Chatelier and Brown in 1884. Thank you very much for watching this video. Do like, subscribe and share my channel. God bless you all. So this is the list of weak electrolytes, non-electrolytes and strong electrolytes. Weak electrolytes are either weak bases, weak acids or few salts. Weak bases, most common weak bases are shown here. Ammonium hydroxide, calcium hydroxide is a mild base. It is not studied under the heading of strong electrolytes. Weak bases, weak acids and few salts are weak electrolytes. Ammonium hydroxide, cupric hydroxides, aluminum hydroxide, beryllium hydroxide, magnesium hydroxide. This is an amphoteric hydroxide, weak base. Calcium hydroxide is a mild base, so it is also treated under the heading of weak electrolytes. Pyridine. So these are weak bases. Weak acids, acetic acid, carbonic acid, phosphoric acid, hydrofluoric acid, nitrous acid, cyanic acid, hydrocyanic acid, sulfurous acid. These are weak acids. Salts, silver chloride, PbCl2, HgCl2, lead chloride, mercury chloride, cadmium sulfate. They are mostly covalent compounds. That's why, though they are salts, but weak electrolytes. So just note down this list, pause the video and note down this list of weak electrolytes. Learn this list of weak electrolytes for your ready reference. These are non-electrolytes. What are non-electrolytes? Which cannot give ions in their molten state or in its aqueous solution. So sucrose, methanol, ethanol, all alcohols, glucose, urea, they are all non-electrolytes. Strong electrolytes, either strong acids, strong bases or most of the salts. Most of the salts are strong electrolytes. So this is the list: HCl, HBr, Hi, HNO3, H2SO4. This is the list of strong acids: hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, sulfuric acid. See, nitric acid is strong. Nitrous acid. Nitric acid is a strong acid. Nitrous acid is a weak acid. Sulfuric acid is a strong acid. Sulfurous acid is a weak acid. Perchloric acid, perbromic acid, periodic acid, chloric acid, bromic acid, fluorosulfuric acid, CF3, SO3H. Strong bases. All alkali metals are strong bases. And alkaline earth metals, as we go down the group, because size increases, so basic character increases. Same is the case here. Strontium hydroxide, barium hydroxide, they are strong bases. bases. Sodium amide, NaNH2, you know it is used in organic chemistry. Sodamide, sodium hydride, and most of the salts are strong electrolytes. So this is the list for your ready reference. You may take screenshot and write down the notes for your exams. Thank you very much. God bless you all. Happy learning. So these are the questions from NCERT. So acid base concept is used. So acid base concept में first we define Lewis concept. तो लुईस कंसेप्ट के अकॉर्डिंग एसिड क्या होता है? एसिड इज इलेक्ट्रॉन एक्सेप्टर. दैट मीन जो इलेक्ट्रॉन पेयर एक्सेप्ट करता है वो होता है एसिड. तो इलेक्ट्रॉन पेयर एक्सेप्ट कौन करेगा? जो क्या होगा? इलेक्ट्रॉन डेफिशिएंट. तो जो भी इलेक्ट्रॉन डेफिशिएंट होगा वो सारे ही लुईस एसिड होंगे. ठीक है. अब आ जाओ बेस. सो बेस क्या होगा? इलेक्ट्रॉन पेयर डोनर, जो इलेक्ट्रॉन पेयर को डोनेट करेगा. तो इलेक्ट्रॉन पेयर डोनेट कौन करेगा? जो इलेक्ट्रॉन रिच होगा. ठीक है. इलेक्ट्रॉन रिच में जिसमें कोई अनशेयर्ड पेयर ऑफ इलेक्ट्रॉन्स होगा वो होगा लुईस बेस. तो अगर हम इसको कंसेप्ट के अकॉर्डिंग ये क्वेश्चन करें, 40th क्वेश्चन कि क्लासिफाई द फॉलोइंग स्पीशीज इनटू लुईस एसिड्स एंड लुईस बेसिस एंड शो हाउ दीज एक्ट एज लुईस एसिड और बेस. तो पहले की बात करते हैं. ये समझ आ गया आपको? लुईस कंसेप्ट मींस इलेक्ट्रॉन पेयर एक्सेप्टर, बेस इलेक्ट्रॉन पेयर डोनर. तो इलेक्ट्रॉन डेफिशिएंट होगा एसिड और इलेक्ट्रॉन रिच होगा बेस, जिसमें अनशेयर्ड पेयर इलेक्ट्रॉन का हो. तो इस क्वेश्चन को अगर करना है तो अब पहला है OH नेगेटिव. अब OH नेगेटिव आयन किस कैटेगरी में है? अब OH नेगेटिव पता है कि O जो है उसने एक बॉन्ड तो बनाया H के साथ, O ने एक बॉन्ड बनाया H के साथ, और O के पास कितने इलेक्ट्रॉन होते हैं? 6 बैलेंस इलेक्ट्रॉन. एक बॉन्ड बना लिया तो 5 बच गए, और एक नेगेटिव है मतलब एक गेन कर लिया. तो ये हुआ. बताओ ये इलेक्ट्रॉन रिच है इलेक्ट्रॉन डेफिशिएंट? इसमें इलेक्ट्रॉन पेयर आ गया ना, अनशेयर्ड पेयर ऑफ इलेक्ट्रॉन है और नेगेटिव चार्ज भी है, इलेक्ट्रॉन रिच. तो क्या बनाई? बेस. तो ये है लुईस बेस. दैट मींस ए जो है अपना ए है लुईस बेस. अब आ जाओ F. फ्लोरीन के पास कितने इलेक्ट्रॉन होते हैं बैलेंस? 7, और एक इसने गेन कर लिया. बोलो क्या बना है? बेस. गेन लुईस बेस. तो ये पहले दो जो हैं वो लुईस बेस है. तो लुईस कंसेप्ट क्लियर हो गया आपको? अच्छा, अब ये दोनों आपके पास आ गए. अब आओ तो H प्लस के पर. बताओ H प्लस क्या होगा? एसिड. एसिड. वेरी गुड. क्योंकि इलेक्ट्रॉन डेफिशिएंट है, इसको इलेक्ट्रॉन चाहिए. BCl3 बताओ. अब BCl3 का सोचो. बोरोन जो होता है बच्चे उसमें 3 इलेक्ट्रॉन बैलेंस होते हैं क्योंकि एटॉमिक नंबर 5 है. तो 2 तो होंगे 1s2 और 2s2 2p1. 3 इलेक्ट्रॉन है और तीनों इसने क्लोरीन के साथ बॉन्ड बनाया. तो 3 तो बॉन्ड पेयर होंगे. कोई और है इलेक्ट्रॉन? नहीं है. तो बोरोन के पास बैलेंस इलेक्ट्रॉन कितने हो गया? 6. 3 इसके अपने और 3 इसने क्लोरीन के साथ शेयर कर लिए. तो टोटल 6 हुए. होने कितने चाहिए? 8. इसका इसका मतलब इसको दो और चाहिए, तो क्या हुआ ये इलेक्ट्रॉन डेफिशिएंट, मतलब इलेक्ट्रॉन एक्सेप्टर हुआ ये, एक इलेक्ट्रॉन पेयर एक्सेप्ट कर सकता है, तो क्या हुआ लुईस एसिड। तो ये बी सी और डी जो है वो क्या हुए लुईस एसिड, और ये दोनों क्या हुए लुईस बेस। तो ये 40th क्वेश्चन समझ आया। ओके, अब इसी क्वेश्चन का दूसरा पार्ट ये भी है 36 क्वेश्चन। इसमें क्या है, एक है H2O। बताओ H2O में दो इलेक्ट्रॉन पेयर होंगे, तो बताओ ये इलेक्ट्रॉन रिच है कि इलेक्ट्रॉन डेफिशिएंट? इलेक्ट्रॉन रिच, क्योंकि अनशेयर्ड पेयर ऑफ इलेक्ट्रॉन आ गए ना, तो ये हो गया इलेक्ट्रॉन रिच मॉलिक्यूल। इलेक्ट्रॉन रिच मॉलिक्यूल क्या होते हैं, जिनमें 8 इलेक्ट्रॉन पूरे हो इस पे ऑक्सीजन पे और अनशेयर्ड पेयर पे, तो ये क्या हुआ लुईस बेस। ठीक है, BF3 बताओ। अभी एग्जाम्पल दिया, बोरोन 3 होता है, वेरी गुड, तीनों बॉन्ड बना लिए, तो क्या हुआ ये एसिड लुईस एसिड, क्योंकि इलेक्ट्रॉन डेफिशिएंट है। सेंट्रल एटम जो है उसके पास 6 इलेक्ट्रॉन है, होने चाहिए 8। अच्छा, H प्लस बताओ, सेम एग्जांपल, इलेक्ट्रॉन डेफिशिएंट लुईस एसिड। और NH4 प्लस, अब मेरी बात सुनना, ऐसा नहीं कि सारे कैटायन जो हैं वो लुईस एसिड ही होते हैं। एक्चुअली ये जो NH4 प्लस है उसमें अगर आप इसका स्ट्रक्चर बनाओ तो कैसा बनेगा, नाइट्रोजन के पास 4 बॉन्ड पेयर ऐसे बनेंगे, नो लोन पेयर, पॉजिटिव चार्ज, बट नाइट्रोजन कोई और इलेक्ट्रॉन गेन करता है, नहीं कर सकता, 8 तो पूरे हो गए इसके, समझे? तो ये लुईस एसिड नहीं है, लुईस बेस भी नहीं है, क्योंकि इलेक्ट्रॉन दे भी नहीं सकता, ना ले सकता है ना, तो नीदर लुईस एसिड नॉर लुईस बेस। तो ये लिमिटेशन होगी किसकी, लुईस कैरेक्टर की, समझे? तो ये क्वेश्चन आपका 36 कर दिया हमने। ठीक है, अब आ जाओ नेक्स्ट क्वेश्चन पे, दैट इज कॉन्जुगेट एसिड बेस, ब्रॉन्स्टेड एसिड, ब्रॉन्स्टेड बेस। तो अब ये था लुईस कंसेप्ट, अब आ जाओ ब्रॉन्स्टेड लोरी कंसेप्ट। ब्रॉन्स्टेड लोरी कंसेप्ट क्या बोलता है कि एसिड गिव्स H प्लस आयन इन एनी सॉल्वेंट, और बेस जो है एक्सेप्ट H प्लस आयन। ठीक है, एसिड गिव्स H प्लस आयन, बेस एक्सेप्ट H, दैट मींस एसिड जो है वो अगर एक H प्लस निकाल दे तो बाकी बचेगा क्या, बेस। उस बेस को बोलते हैं कॉन्जुगेट बेस। ठीक है, जैसे मैंने लिखूं मैं HCl, HCl से क्या बनेगा, H प्लस निकाल दिया तो बचेगा क्या, तो ये इस एसिड का ये कॉन्जुगेट बेस होगा, समझे? वैसे ही बेस क्या करता है, एक्सेप्ट H प्लस आयन एक्सेप्ट करता है, तो क्या बनता है कॉन्जुगेट एसिड। ठीक है, जैसे मैं लिखूं CO3 2 नेगेटिव, एक H प्लस गेन किया, क्या बन गया HCO3 नेगेटिव। तो ये अगर ये हुआ बेस और ये इसका कॉन्जुगेट एसिड, समझे? मतलब एसिड और बेस में एक H प्लस का डिफरेंस होता है, एक H प्लस ज्यादा होगा एसिड में और एक कम होगा बेस। सिंपल, क्लियर हो गया?
Yes, sir.
अब आ जाओ आप ये 39 क्वेश्चन। क्या बोल रहा है कि स्पीशीज ये दिए हुए आपको, एक्ट बोथ, ब्रोंसिड एसिड भी है,
Base.
बेस भी है, ठीक है? तो फॉर ईच केस गिव कॉरस्पॉन्डिंग एसिड एंड बेस, कॉन्जुगेट एसिड बेस, ठीक है? ये कर दो,
Yes, sir.
समझा है?
Yes, sir.
अच्छा, तो अब आ जाओ, पहले आ जाओ H2O। ये स्पीशीज है, अगर मैं एक H प्लस डाल दूं तो H3O प्लस बनेगा। ये क्या बना इसका, एसिड या बेस?
Acid.
वेरी गुड, इट इज कॉन्जुगेट एसिड बिकॉज इट हैज वन H प्लस आयन मोर देन दिस। और अगर मैं OH नेगेटिव बनाऊं तो
Base.
बेस, तो ये बन गया आपका कॉन्जुगेट बेस, आपका नहीं H2O, ठीक है?
Yes.
ओके, देन HCO3 नेगेटिव, तो HCO3 नेगेटिव का एसिड बोलो, एक H प्लस डाल दो
H2CO3.
और एक H प्लस निकाल दो,
CO3 2 minus.
इस स्पीशीज का ये स्पीशीज हुए
Yes.
और ये इसका कॉन्जुगेट बेस बन रहा है और ये कॉन्जुगेट एसिड। HSO4 नेगेटिव, आप ये बोल जरा,
Yes.
कॉन्जुगेट एसिड
एक H प्लस ऐड कर
Yes.
देंगे
तो क्या बनेगा?
H2SO4।
हाँ, H2SO4 इसका कॉन्जुगेट एसिड, तो बोल कुणाल कॉन्जुगेट बेस।
Minus कर देंगे हमें.
हाँ, तो बता क्या है?
SO4 2 minus.
वेरी गुड, SO4
2 minus.
2 माइनस, तो समझ आ रहा है आपको? अच्छा, NH3 का कॉन्जुगेट एसिड बोल।
Add कर देंगे सर.
हाँ, तो क्या
NH4
प्लस, है ना? और ये
NH2 negative.
ठीक है, बिल्कुल सिंपल है। एक H प्लस कम होगा तो कॉन्जुगेट बेस, एक H प्लस ज्यादा होगा तो कॉन्जुगेट एसिड। ठीक है, 39 क्वेश्चन हो गया।
Yes.
अच्छा, अब बताओ, ये NH2 है, NH3 है और HCO नेगेटिव है, तो अब बताओ, आपको बनाना है ब्रोंस्टेड बेस। राइट द कॉन्जुगेट एसिड ऑफ दिस NH2 नेगेटिव का कॉन्जुगेट एसिड बोलो।
NH3.
वेरी गुड, NH3। NH3 का कॉन्जुगेट एसिड बोलो।
NH4 plus.
बिल्कुल सही जवाब, HCO नेगेटिव,
HCOH.
HCOH, सिंपल है। अच्छा, 37 का आपको बताना है कॉन्जुगेट बेस। HF का कॉन्जुगेट बेस बोलो।
F negative.
वेरी गुड, एक H प्लस का। अच्छा, फिर H2SO4 का बोलो।
HSO4 negative.
गुड, HSO4 नेगेटिव और HCO3 नेगेटिव का बोलो।
CO3 2 minus.
CO3 2 माइनस, गुड। अच्छा, उसके बाद आ जाओ, लास्ट क्वेश्चन है इसका, व्हाट इज मेंट बाय कॉन्जुगेट एसिड बेस पेयर? वो मैंने ऑलरेडी समझा दिया आपको।
Yes, sir.
कि conjugate acid base pair differ by one H plus ion, clear? और find the conjugate acid और base of the species। अब बताओ, HNO2 जो है वो एक H plus दे सकता है, इसका मतलब H plus देगा तो जो बचेगा H plus देने के बाद वो क्या बनाएगा? H plus दे दिए इसने,
Conjugate base.
वेरी गुड, मतलब ये एसिड एक्ट कर रहा है। अब बताओ F नेगेटिव क्या करेगा? H प्लस तो उसके पास है नहीं, तो दे तो सकता नहीं, एक्सेप्ट करेगा। तो जो एक्सेप्ट करता है वो क्या बनता है?
Conjugate acid.
कॉन्जुगेट एसिड, ये बेस की तरह एक्ट कर रहा है। फिर आ जाओ OH नेगेटिव, H प्लस भी दे सकता है, क्या करेगा?
Accept करेगा.
H प्लस एक्सेप्ट करेगा, क्या बना?
Conjugate acid.
कॉन्जुगेट एसिड, गुड। CO3 2 नेगेटिव,
Accept करेगा.
एक्सेप्ट करेगा H प्लस, क्या बनाएगा?
Conjugate acid.
CO3
Negative.
क्या बनाएगा?
Conjugate acid.
Conjugate acid। और लास्ट है S2 नेगेटिव,
Accept करेगा.
HS।
Negative. Conjugate acid.
हाँ प्लीज कीप इन माइंड, ऐसा नहीं कि S2 नेगेटिव है तो आप 2H प्लस ऐड कर दो और बोलो कि ये H2S बन गया तो वो कॉन्जुगेट एसिड हुआ। नहीं, वो कॉन्जुगेट एसिड नहीं हुआ, वो कॉन्जुगेट एसिड इसका बनेगा। समझे? याद रखना एक H प्लस का डिफरेंस होना चाहिए। ठीक है, ये तो दो कंसेप्ट हो गए, एक लुईस कंसेप्ट था, दूसरा क्या था?
Conjugate acid.
ब्रॉन्स्टेड-लोरी कंसेप्ट। दूसरे को बोलते हैं ब्रॉन्स्टेड-लोरी कंसेप्ट। इसमें एक और चीज याद रखनी है आपको कि अगर मान लिया आपके पास स्ट्रॉन्ग एसिड है जैसे HClO4, तो उसका जो बेस होगा वो वीक होगा। स्ट्रॉन्ग एसिड हैज वीक कॉन्जुगेट बेस। स्ट्रॉन्ग एसिड हैज वीक कॉन्जुगेट बेस, क्योंकि स्ट्रॉन्ग एसिड गिव H प्लस आयन इजीली। H प्लस देने के बाद जो बनेगा वो स्टेबल होगा। समझा गया? तो स्ट्रॉन्ग एसिड के इक्विलिब्रियम इधर शिफ्ट होगा, बैकवर्ड कम होगा। इसका मतलब इसको अगर हम बनाएंगे तो ऐसे बनाएंगे, समझे? कि ये इधर ज्यादा है और इधर कम। स्ट्रॉन्ग एसिड ऐसा होगा और वीक होगा तो उल्टा कि वीक एसिड हैज स्ट्रॉन्ग कॉन्जुगेट बेस। ठीक है, लास्ट कंसेप्ट है आरएमएस कंसेप्ट। आरएमएस कंसेप्ट क्या है कि एसिड जो है वो वेल नोन है, आप 10th में पढ़ते हो। एसिड गिव्स H प्लस आयन और बेस गिव्स OH माइनस आयन। बट इसकी लिमिटेशन क्या है? ये होता है इन एक्वस सॉल्यूशन। याद रखना, इन एक्वस
Solution.
ये होता है सिर्फ पानी में ही ऐसा होगा कि जो पानी में एसिड H प्लस दे वो एसिड, जो पानी में OH नेगेटिव दे वो बेस। बट ब्रॉन्स्टेड-लोरी क्या बोलता है? गिव H प्लस आयन एसिड इन एनी सॉल्वेंट
And base except for H plus.
H प्लस आयन। ठीक है, सॉल्वेंट की कोई लिमिटेशन उसमें उसने लिमिट नहीं रखी। ठीक है, थैंक यू वेरी मच फॉर वाचिंग दिस वीडियो। डू लाइक, शेयर, comment and subscribe my channel so that you will get press the bell icon so that you will get notification of my next video. Thank you very much. Welcome back. I am Dr. Suresh, your tutor, your mentor, your friend. Today we are going to learn ionization of water. It is also known as autoprotolysis. Also going to study ionic product of water. So actually water is a very weak electrolyte. One water molecule gives its H plus ion to the other water molecule and we get H3O plus aqueous, OH negative aqueous. So this is ionization of water. This is also known as autoprotolysis of water because proton is automatically shifted from one water to another, and in this way breaking takes place. We get ions instead of neutral water molecules. So H2O react with another H2O and transfer of H plus takes place to give H3O plus, that is called hydronium ion, and OH negative ion, that is called hydroxide ion. So according to law of chemical equilibrium, the equilibrium constant is H3O plus ion concentration, OH negative ion concentration divided by H2O liquid power 2. But you know, this pure liquid has constant molarity, that implies K into H2O liquid square, H2O plus into OH negative, and this is known as ionic product of water. Kw is equal to H3O plus ion concentration into OH negative concentration, and value of Kw is constant at constant temperature. At 298 Kelvin, value of Kw is 10 raised power minus 14 mole square per liter square, because it is mole per liter, so it becomes mole raised power 2, liter raised power minus 2. Now, what happened if we increase the temperature? What is the effect on the value of Kw of increasing temperature? When we increase the temperature, ionization increases. As ionization increases, concentration of H3O plus and OH negative ion increases. As concentration of H3O plus and OH negative increases, so is Kw. That means on increasing temperature, Kw increases. On increasing temperature, Kw increases. And water is a neutral solution. For water, H3O plus concentration is equal to OH negative ion concentration, and that's why this Kw is equal to, and say it is X, so Kw equal to X into X, and that is equal to 10 raised power minus 14 at 298 Kelvin. It is X square. X is equal to 10 raised power minus 14 half. So X is equal to 10 raised power minus 7 mole per liter. That means H3O plus concentration as well as OH negative ion concentration is equal to 10 raised power minus 7 for neutral solution. For water, H3O plus concentration is equal to OH negative ion concentration. That means for any neutral solution, concentration of H3O plus is equal to OH negative. Thank you very much for watching this video. Do like, subscribe and share my channel. God bless you all. Welcome back, friends. Today's topic is strong and weak electrolyte. So first, what is electrolyte? So electrolyte is a substance which either in molten state or in aqueous solution can conduct electricity. And as current is carried by ions, so electrolyte is either ionic or it furnish ions in its aqueous solution. For example, NaCl. NaCl is an ionic compound. It has already ions, Na plus Cl negative. In solid state, it cannot conduct electricity because ions are fixed. But in molten state, ions are free to move. It gives Na plus and Cl negative ion. That's why NaCl is a good conductor of electricity in molten state. NaCl solid, when we melt it, we get Na plus and Cl negative ion, and that's why NaCl is a strong electrolyte because it dissociates completely. So what is a strong electrolyte? The electrolyte which dissociate or ionize completely into its ions. For example, HCl. When HCl is dissolved in water, it gives H3O plus and Cl negative. So HCl is also a strong electrolyte. In case of strong electrolytes, ionization is represented by a single arrow. electrolyte which dissociate completely into ions are known as strong electrolytes, and which dissociates to certain extent, to some extent, that is called weak electrolyte. Strength of an electrolyte is expressed in terms of degree of ionization. And degree of ionization is represented by alpha. It is equal to number of molecules of electrolyte which split into ions to the total number of molecules of the electrolyte. And for strong electrolytes, alpha is close to 1. Means all the molecules of the electrolyte dissociates into ions. But for weak electrolytes, alpha is very less than 1. For example, acetic acid. It is a weak acid. When dissolved in water, its ionization is represented like this. There is an equilibrium between unionized molecules and ionized molecules. There is an equilibrium. But NaCl, when dissolved in water, it is represented like this. It is expressed by single arrow and it is represented by double-headed arrow, and this is known as equilibrium. In weak electrolytes, unionized form and ionized form is in equilibrium, but in case of strong electrolytes, there is no equilibrium. It is in equilibrium only when we have a saturated solution of strong electrolytes. You know, NaCl is solvent in water, but if we keep on dissolving NaCl, our stage is reached when it is in equilibrium, then it is represented in terms of equilibrium. If solution is dilute, then weak acid, weak base, weak electrolyte is expressed in terms of equilibrium, but strong electrolytes is expressed by single arrow. Weak acids, weak bases, and few salts are weak electrolytes, and strong acids, strong bases, and most of the electrolytes are strong electrolytes. Ostwald dilution law. So let us take an example of a salt in aqueous solution which is in equilibrium with A positive and B negative. That means this is a weak salt, weak acid, or weak base. Weak salt, weak acid, or weak base, because its unionized form and ionized form, they are in equilibrium. So initially, let us start with concentration C. It has concentration C. That means it is 0 in the beginning of the reaction. Now at equilibrium, let us suppose alpha is the degree of dissociation. C is the molar concentration of the salt. Alpha is degree of dissociation. It means out of 1, alpha is dissociated. Out of 1, alpha dissociates. So out of C alpha is dissociated. if one AB is dissociated, we get 1A plus 1B negative. That means if C alpha dissociates, then it is C alpha, C alpha. According to law of equilibrium, equilibrium constant K is equal to concentration of A plus concentration of B negative divided by concentration of AB aqueous. It means it is C alpha into C alpha divided by C minus C alpha. C alpha into C alpha divided by C 1 minus alpha. 1 C is cancelled. So we get C alpha square over 1 minus alpha. Now for weak electrolytes, alpha is very less than 1. As alpha is very less than 1, 1 minus alpha is very close to 1. That means alpha can be neglected as compared to 1. So it means equilibrium constant K is equal to C alpha square. So there's alpha square equal to Ka over C. That implies alpha is equal to square root of K over C. And if V is the volume containing 1 mole of electrolyte, means C is equal to, what is C? Number of moles over volume. So number of moles is 1 divided by V. This is the V volume containing 1 mole of electrolyte. So that implies alpha equal to square root of K into V. So this is Ostwald's dilution law. Now this equilibrium constant for weak electrolytes, and this equilibrium constant for the electrolyte is known as dissociation or ionization constant. So this is dissociation or ionization constant of electrolyte. That means Ostwald dilution law is defined as, in case of weak electrolytes, degree of dissociation alpha is inversely proportional to square root of molar concentration or directly proportional to square root of volume which contains 1 mole of electrolyte. And this is called Ostwald's dilution law. This is Ostwald dilution's law, that in case of weak electrolyte, degree of dissociation or degree of ionization alpha is inversely proportional to square root of concentration or directly proportional to square root of volume V containing 1 mole of electrolyte. For an acid, ionization constant is Ka. So alpha is equal to square root of Ka over C. This is called, Ka is ionization constant of acid. For a base, ionization constant is Kb. Alpha is square root of Kb over C. Ostwald dilution law is applicable for weak electrolytes only. In case of strong electrolytes, no equilibrium is present. That's why we cannot apply this law for strong electrolytes. Thank you very much for watching this video. Do like, subscribe and share my channel. God bless you all. Happy learning. I am Dr. Suresh Thakur, your mentor, your tutor for chemistry. Today let us discuss H3O plus and OH negative ion concentration in aqueous solutions of acids and bases. We know that in water H3O plus concentration is equal to OH negative ion concentration and is equal to 10 raised to power minus 7 at 298 Kelvin. 10 raised to power minus 7 molar at 298 Kelvin. Now case 1. If we add acid, in pure water we add acid, let us say HCl. When we add HCl in water, then it gives H3O plus and Cl negative ion. Now extra H3O plus ions are added in the water, so H3O plus ion becomes greater than OH negative ion, and you know Kw is equal to H3O plus into OH negative. That implies H3O plus is equal to Kw by OH negative, or OH negative ion is equal to Kw divided by H3O plus. As H3O plus is greater than OH negative, means H3O plus ions are greater than in the pure water. It implies H3O plus ion concentration is greater than 10 raised to power minus 7. It means OH negative ion is equal to Kw divided by greater than 10 power minus 7, because H3O plus ions are greater than 10 raised to power minus 7 molar. So it becomes, the value becomes less than 10 raised to power minus 7 molar. So what it means? H3O plus ions are greater than 10 raised to power minus 7 molar, and OH negative ions are less than 10 raised to power minus 7 molar in case of we add acid in water. So ultimately it become H3O plus is greater than OH negative ion, or H3O plus is greater than 10 raised to power minus 7 for acidic solution, because when we add acid, its solution becomes acidic, and H3O plus ions are greater than OH negative ions. Case 2. If we add base. What are bases which gives OH negative ions? Let us say NaOH. When we add NaOH in water, it gives Na plus and OH negative ions. So OH negative ions becomes greater than in pure water. So if OH negative ion is greater than 10 raised to power minus 7 molar, that means H3O plus become less than 10 to the power minus 7 molar, because Kw is fixed. Kw is H3O plus ion concentration, OH negative ion concentration, and is equal to 10 raised to power minus 14 mole square per liter square at 298 Kelvin. At constant temperature, Kw is constant. So if at 298 Kelvin temperature, H3O plus is less than 10 raised power minus 7 molar, means OH negative ion is greater than 10 raised power minus 7 molar. In basic solution, OH negative ion becomes greater than H3O plus. So you can say for pure water, H3O plus is equal to OH negative. For acidic solution, H3O plus is greater than OH negative. For acidic solutions, H3O plus is greater than OH negative, and for basic solution, H3O plus is less than OH negative, or we can say OH negative ions are greater than H3O plus. Thank you very much for watching this video. Do like, subscribe and share my channel. God bless you all. Thank you very much. Happy learning. Welcome back, friends. I am Dr. Suresh Thakur, your mentor, tutor for chemistry. Today we will learn what is pH scale for expressing hydrogen ion concentration, and we will prove that pH plus pOH is equal to 14 at 298 Kelvin. First, what is pH? So pH is defined as negative logarithm of H3O plus ion concentration. Negative logarithm of H3O plus ion concentration. See, pH equal to minus log of H3O plus. It is also equal to H3O plus raised to power minus 1, or log of 1 upon H3O plus. So it can also be defined as logarithm of reciprocal of H3O plus ion concentration. The square bracket means molar concentration of H3O plus ion, or whatever the quantity or species is present in the square bracket, it indicates molar concentration of that particular species, molarity of that particular species. So on the same line, we can define pOH. What is pOH? It is negative log of OH negative ions. So what it means? If HCO plus ions are more, pH value is less, because it is negative log of HCO plus ion concentration, or it is log of reciprocal of HCO plus ion. That means pH and HCO plus ion concentration, there is an inverse relation. If HCO plus ions increases, pH decreases. On the same line, any number px, it means minus log of x. pKa, that is dissociation constant of acid, pKa is minus log of Ka. pKb, minus log of Kb. pKw, minus log of Kw. Now, to prove that pH plus pOH equal to 14, we know that Kw, this is ionic product of water, is equal to H3O plus ion concentration into OH negative ion concentration, and is equal to 10 raised to power minus 14 at 298 Kelvin. Now taking log on both sides. So log of Kw is equal to log of H3O plus ion into OH negative equal to log of 10 raised to power minus 14. Now just apply the laws of logarithm. Log of a into b equal to log a plus log b. Log a by b equal to log a minus log b. Log a raised to power n equal to n log a, and log of 10 is equal to 1, and log of 1 is equal to 0. And if we write log, that means its base is 10. All have base 10. That is called common log. Second is natural log. Natural log of x is equal to log of base e of x. Natural log means base e. To convert it into common log, we multiply it by 2.303. Its base is 10. Because base 10 is common, so there is no need to write it. And if you write it, it's okay. But if nothing is written, its base is 10. Common log and natural log, they are related by this number 2.303. Just apply. Log of kW is equal to log of a into b. So what is log a into b? Log a plus log b. So log of H3O plus log of OH negative, and is equal to log a raised to power n, is n log a, so minus 14 log 10. Now just multiply the whole by minus 1. If you multiply it by minus 1, it becomes minus log of kW is equal to minus log of H3O plus minus log of OH negative equal to 14 log 10, and you know log 10 is 1, so it is 14. What it becomes? Minus log of kW, pKW, minus log of H3O plus pH, minus log of OH negative, POH, and it become 40. So pH plus POH equal to 40, or pH is equal to 14 minus POH, and POH equal to 14 minus pH, and pKW is equal to 40. Now as we have discussed that for neutral solution H3O plus ion concentration is equal to OH negative ion concentration is equal to 10 raised to power minus 7. So that means, what is pH? So pH is equal to minus log of H3O plus, and POH minus log of OH negative. So it becomes minus log of 10 raised to power minus 7. So minus 7, just apply this law of logarithm, it becomes 7 log 10, and log 10 you know is 1. Same is the case here. Again 7. That means pH is equal to POH is equal to 7 for neutral solutions. For acidic solutions, H3O plus ions are greater than 10 raised power minus 7. So pH is less than 7. If pH is less than 7, pOH is greater than 7. For acidic solutions, pH is less than 7, pOH is greater than 7, because OH negative ions are less than 10 raised to the power minus 7 molar. For basic solutions, which ions are greater? OH negative ions are greater than 10 raised to the power minus 7, and H3O plus ions are less than 10 raised to the power minus 7. It means pOH is less than 7, so pH is greater than 7. So for basic solutions, pH is greater than 7, pOH is less than 7. Acidic solutions, pH is less than 7, pOH is greater than 7. And this is all at 298 Kelvin. Remember, this is all at 298 Kelvin. If we increase the temperature, might be solution is neutral at pH 6. We will discuss the case, because when we increase the temperature, Kw increases. If Kw increases, let us say at 100 degrees Celsius, Kw is 10 raised to the power minus 12. If Kw is 10 raised to the power minus 12, so H3O plus sign for neutral solution is 10 raised to the power minus 6. So pH is 6 for a neutral solution at higher temperature. But on the standard basis, we take into account 298 Kelvin, and we say that pH scale varies from 0 to 14. It may be less than 0, it may be greater than 14, but on standard basis, the scale is 0 to 14. Standard basis, we call that if pH is 0, that means pH is very less than 7, strongest acid. If pH is 14, very greater than 7, that is the strongest base, and solution is highly basic. That's all about pH and pOH, and how do we predict that whether the solution is neutral, acidic or basic on pH scale. God bless you all. Happy learning. Let us consider a weak monobasic acid whose concentration is given to you as HA. When it is dissolved in water, we get H3O plus and A negative. So in this expression, if C is concentration of HA, this is 0, 0. If alpha is degree of dissociation, then it becomes C minus C alpha, C alpha, C alpha. So Ka H3O plus A negative to HA, that is Ka equal to C alpha into C alpha divided by C minus C alpha, means C is common, so C into 1 minus alpha, that is Ka equal to C alpha square or 1 minus alpha. For weak acid, alpha is very less than 1, so 1 minus alpha is around about 1. So Ka is equal to C alpha square, or alpha is equal to under root Ka over C. Now H3O plus ion concentration is equal to C alpha, and alpha is square root of KAC. If C and alpha is given, you should write both and calculate H3O plus and pH accordingly. But if Ka and C is given, alpha is Ka over C, C becomes C square inside the square bracket, so it is square root of Ka into C. So H3O plus is equal to square root of Ka into C, and pH is equal to minus log of H3O plus, and that is equal to minus log of Ka into C raised to power half. So it becomes minus half log of Ka plus log of C. Minus log Ka into C means log A into B, log A plus log B. So minus inside become minus log of Ka minus log of C. And what is minus log of Ka? pKa. So pH is equal to half of pKa minus log of C. So for weak acids, you can calculate H3O plus by using this relation, square root of Ka into C, dissociation constant of acid and concentration. If given, you can calculate H3O plus. You can calculate pH by using this relation, half of pKa minus log of C, or you can calculate alpha by using this relation, square root of Ka over C. These expressions can be used to calculate alpha, H3O plus, pH in case of weak acids for numerical purpose. Thank you very much for watching this video. Do press thumbs up button if you like it, and subscribe my channel. To calculate pH, pOH, OH negative ion concentration and degree of dissociation for weak bases. Let us consider weak base. BOH, it gives B plus, and OH negative ion concentration. Initially concentration is C, it is 0, 0. At equilibrium, if alpha is degree of dissociation, then it becomes C minus C alpha. If one BOH gets dissociated, we get one B plus and one OH negative. As C alpha gets dissociated, it becomes C alpha and C alpha. So dissociation constant of base Kb is equal to B plus ion concentration, OH negative ion concentration divided by BOH concentration. So Kb is equal to C alpha into C alpha divided by C minus C alpha. So Kb is equal to C alpha square divided by 1 minus alpha. C is common, and for weak bases, alpha is very less than 1. 1 minus alpha is round about 1. So Kb become equal to C alpha square, and alpha is equal to square root of Kb by C, because alpha square equal to Kb by C and alpha is square root of Kb over C. And what is OH negative ion concentration? C alpha, and alpha is square root of Kb over C. It become square root of Kb into C. So POH is equal to minus log of OH negative, that is minus log of Kb to C raised to power half. Half is common, it is minus log of Kb minus log of C. You know that pH is equal to 14 minus half of pKb minus log C, because for pH equal to 14 minus POH. Thank you very much for watching this video. If you like this video, do press thumbs up button so that I will come to know that you like it. God bless you all. Happy learning. I am Dr. Suresh Thakur, your mentor, your tutor for chemistry. Today we will learn the relation between Ka and Kb. What is Ka? Dissociation constant of acid, and Kb, dissociation constant of base for an acid and its conjugate base. Let us consider a weak acid, Ha, which ionizes in water to give H3O plus aqueous and A negative aqueous. So Ka for given acid is equal to H3O plus ion concentration, A negative ion concentration divided by Ha concentration. Now, if it is an acid, so according to Bronsted-Lowry concept, if Ha is acid, then its conjugate base is A negative, because conjugate acid base pairs differ in one H plus ion. Acid has one more H plus ion than base. So you can see in A negative there is no H, in Ha there is one H. This is a monobasic acid. The acid which gives only one H plus ion is known as monoprotic or monobasic acid. Now, conjugate base. When conjugate base is dissolved in water, we will get Ha, because A negative ion accept H plus ion and gives OH negative ion. So in this way, Kb is equal to Ha into OH negative ion divided by A negative ion. Now you have Ka, Kb. This is dissociation constant of acid, and this one is dissociation constant of conjugate base. Dissociation constant of acid, dissociation constant of conjugate base. Now just multiply Ka and Kb. So Ka into Kb is equal to H3O plus into A negative divided by HA into HaOH negative divided by A negative. Now A negative cancelled by A negative, HA cancelled by HA. What is left? H3O plus and OH negative. So this equation Ka into Kb is equal to H3O plus ion concentration into OH negative. And what is this? Product of H3O plus and OH negative. We have already done it. Yes, it is Kw. So Ka into Kb is equal to Kw. That is ionic product of water. So this is the relation between Ka and Kb. Product of dissociation constant of acid and dissociation constant of conjugate base is equal to ionic product of water. And you know it is equal to 10 raised to power minus 14 at 298 Kelvin. To proceed further, taking log on both sides, log Ka into Kb equal to log of Kw. So it becomes log of Ka plus log of Kb because it is log A into B. So log A into B is log A plus log B, and is equal to log of Kw. Multiply the whole equation with minus 1. So it becomes minus log of Ka plus minus log of Kb equal to minus log of Kw. What is this? Minus log of Ka is pKa, minus log of Kb is pKb, and minus log of Kw pKw. So pKa plus pKb is equal to pKw, and as Kw is equal to, because Kw is equal to 10 raised power minus 14, so pKw equal to 14. This way pKa plus pKb is equal to 14 at 298 Kelvin. That's all about the relation between Ka and Kb for an acid and its conjugate base. Thank you very much for watching this video. If you like this, do press thumbs up button. God bless you all. Common ion effect. I am Dr. Suresh Thakur, your friend, your mentor, and your tutor for chemistry. Today we will discuss new topic, that is common ion effect. As the name suggests, there is one common ion in the solution. For example, let us take ammonium hydroxide. You know, ammonium hydroxide is a weak electrolyte, that is a weak base. It gives NH4 plus ions and OH negative ion. If we add a strong electrolyte like ammonium chloride, it has a common ion, and due to the presence of common ion, one of the product is increased in the equilibrium. And according to Chatellier's principle, if one of the product is increased, equilibrium shifts backward. So when this equilibrium shifts backward, what happened? Dissociation of weak is further suppressed, further decreased due to the presence of a common ion in the equilibrium. Another example, we have acetic acid. Acetic acid, when dissolved in water, because it is a weak acid, it is in equilibrium with acetate ion and HCO plus ion, and when we add a strong electrolyte like sodium acetate, it dissociates completely to give acetate ion and sodium ions. Now this is common ion, and due to the common ion, one of the product is increased in the equilibrium. Equilibrium shifts backward, so dissociation of weak acid is suppressed, is decreased further due to the presence of common ion. This is called common ion effect. To define it, it is defined as suppression, dissociation of weak electrolyte due to the presence of a strong electrolyte having a common ion. So common ion effect is suppression or decrease in the dissociation of a weak electrolyte by the addition of a strong electrolyte having a common ion. Dissociation of weak acid or dissociation of weak base by the addition of, decrease in the dissociation of weak base or decrease in the dissociation of weak acid by the addition of a strong electrolyte having a common ion is known as common ion effect. Thank you very much for watching this video. If you like this video, do press thumbs up button. God bless you all. Thank you very much. Om Shanti. Welcome back, students. Today we will learn salt hydrolysis. So what is salt hydrolysis actually? First, what is salt? Salt has cation and anion, right? So when the salt, cation and anion or both of a salt interact with water, which gives acidic, basic or neutral solution, that is called salt hydrolysis. But condition apply. What is the condition? That at least one of them, either acid or base, should be weak, or if both are weak, then even then there is salt hydrolysis. So अब जैसे मैं एग्जांपल लेता हूं NaCl. अब NaCl में कौन से आयन है?
Na plus और Cl minus.
Na plus and Cl negative. When these ions interact with water, क्या मिलेगा हमें? NaOH and Cl नेगेटिव क्या बनाएगा? HCl. तो एक बनेगा NaOH और दूसरा HCl. इन दोनों में से कोई वीक है? No. Means it is strong base and this is strong acid. इसका मतलब NaCl cannot be hydrolyzed. Even हम एग्जांपल लेते हैं KNO3. कौन से वाटर से इंटरेक्ट करने से क्या बनाएगा ये? एक KOH और साथ में HNO3. बताओ. तो both are strong. ये strong base और ये strong acid. इसका मतलब KNO3 also cannot be hydrolyzed. तो आपको याद रखना है कि salt of strong base and strong acid cannot be hydrolyzed. तो क्वेश्चन उठता है कि इसकी पीएच क्या होगी फिर? अगर इसको पानी में डाल दिया तो व्हाट इज द पीएच? यस, पीएच इज 7. नियर अबाउट नहीं, पीएच इज 7 ओनली. ठीक है, सो इसकी पीएच हमेशा क्या होगी? 7. अगर कोई क्वेश्चन आता है कि कोई भी कॉन्सेंट्रेशन दे दिया आपको कि इस NaCl मान लिया 0.1 मोलर NaCl, 0.01 मोलर NaCl, कोई भी मोलर NaCl, x मोलर NaCl, सो व्हाट इज pH? तो आप लिखोगे 7। समझ गए पॉइंट? ओके, तो फर्स्ट पॉइंट हो गया आपका कि सॉल्ट ऑफ स्ट्रॉन्ग बेस एंड स्ट्रॉन्ग एसिड कैन नॉट बी हाइड्रोलाइज्ड। और एल्कली मेटल के जितने भी सॉल्ट होते हैं वो तो स्ट्रॉन्ग बेस ही बनाएगा, ठीक है। तो और कोई HCl बन रहा है, HNO3 बन रहा है, H2SO4 बन रहा है, तो स्ट्रॉन्ग एसिड, ठीक है। ओके, नाउ सेकंड इज सॉल्ट ऑफ स्ट्रॉन्ग एसिड एंड वीक बेस। बोलो कोई एग्जांपल। स्ट्रॉन्ग एसिड, वीक बेस। जैसे मैं लूं
सोडियम एसिटेट,
अमोनियम क्लोराइड। सोडियम एसिटेट बेटा स्ट्रॉन्ग बेस और वीक एसिड हो। तो अमोनियम क्लोराइड लिया मैंने, तो अमोनियम क्लोराइड को वाटर में डालूंगा तो बताओ क्या बनेगा? देखो अमोनियम आयन मिलेगा और साथ में Cl नेगेटिव आयन, अमोनियम और ये क्या देगा? H+ एंड OH नेगेटिव, तो NH4 क्या बनाएगा?
NH4OH,
हाँ NH4OH, और Cl नेगेटिव HCl। HCl क्या है? स्ट्रॉन्ग एसिड। और ये तो बताओ सोल्यूशन का नेचर कौन डिसाइड करेगा?
स्ट्रॉन्ग होगा,
स्ट्रॉन्ग। तो मतलब कि ये जो भी सोल्यूशन होगा, याद रखना कि ये हमेशा क्या होगा? एसिडिक। पहला तो पॉइंट ये होगा कि ये एसिडिक सोल्यूशन होगा। तो एसिडिक सोल्यूशन होगा तो पीएच क्या होगी? पीएच लेस देन 7। समझे ना? दूसरा पॉइंट कि अगर पीएच लेस देन 7 होगी, इसका मतलब ये हुआ, और कौन सा पार्ट हाइड्रोलाइज हुआ?
कैटायनिक।
वेरी गुड। सो इट इज एन एग्जांपल ऑफ बोलो कैटायनिक हाइड्रोलिसिस। ओनली कैटायन इज हाइड्रोलाइज्ड, एनायन इज नॉट हाइड्रोलाइज्ड, क्योंकि एनायन क्या है? स्ट्रॉन्ग एसिड बना रहा है। तो स्ट्रॉन्ग एसिड अगर बनाएगा तो वो किस फॉर्म में रहेगा? H+ अलग, Cl नेगेटिव अलग, हाइड्रोलाइज नहीं हुआ ना, इंटरेक्ट नहीं किया, वो अलग अलग रहे, ठीक है। अब अगर ये हाइड्रोलाइज हो रहा है तो इसका क्या होगा? हाइड्रोलिसिस कांस्टेंट, ठीक है। और वो जो हाइड्रोलिसिस कांस्टेंट होगा, अब आपको याद रखना है कि कौन सा पार्ट हाइड्रोलाइज हो रहा है? कैटायन। और क्या बना रहा है वो? बेस, वीक बेस। तो याद रखना कि ऊपर आएगा KW, आयनिक प्रोडक्ट ऑफ वाटर, और नीचे क्या आएगा? KB। कीप इन माइंड, जो वीक होगा वो नीचे आएगा, ठीक है। और डिग्री ऑफ हाइड्रोलिसिस क्या होती है? जैसे आपने पढ़ा होगा डिग्री ऑफ डिसोसिएशन √KA/C या √KB/C, है ना, वीक एसिड के लिए, वीक बेस के लिए। वैसे ही H क्या होता है? डिग्री ऑफ हाइड्रोलिसिस। तो ये होगा √ वहां Ka भी आता था, और ये है डिग्री ऑफ हाइड्रोलिसिस, तो क्या आएगा? हाइड्रोलिसिस कांस्टेंट बाय C, और दैट इज 100। और KH क्या होता है? KW/KB/C। समझाया था ना? और pH क्या है? लेस देन 7। pH is less than 7, that means it is 7 minus half pKb plus log C। तो ये साइन जो है वो आपका माइनस क्यों आया? यहीं से क्लियर होगा कि माइनस साइन आएगा, 7 से माइनस होगा कुछ, तो 7 से माइनस होगा ये। क्यों? KB, देखो हर जगह KB यूज हुआ, क्यों? क्योंकि वही पार्ट हाइड्रोलाइज हो रहा है, तो याद रखना है, ठीक है। जब मैं इसको करूं वीक एसिड और इसको स्ट्रॉन्ग बेस, तब जो है अभी स्ट्रॉन्ग ही रहने देते हैं क्योंकि अभी इसको एग्जाम्पल चल रहा है, पर जब इसको वीक करूंगा तो आपको क्लियर होगा कि ये इसी से आप उसको कन्वर्ट कर सकते हो। ठीक है, अच्छा और कोई एग्जाम्पल दो और अमोनियम क्लोराइड के अलावा। कॉपर सल्फेट, कॉपर सल्फेट लिया, ठीक है, या मैंने फेरिक क्लोराइड लिया, तो दोनों ही देखो कॉपर क्या देगा वाटर से इंटरेक्ट करके CuOH ट्वाइस प्लस H2SO4, और ये क्या देगा FeOH थ्राइस प्लस 3HCl। तो याद रखना ये वीक बेस है, ये भी वीक बेस है, और ये स्ट्रॉन्ग एसिड, तो ये भी हाइड्रोलाइज होंगे और एसिडिक होंगे सॉल्ट। ठीक है, कर लोगे इतना। अब मैं इसको करता हूं सॉल्ट ऑफ वीक एसिड और बेस स्ट्रॉन्ग। बोलो एग्जाम्पल।
सर अमोनियम सल्फेट कैसा होगा?
अमोनियम सल्फेट बेटा, अमोनियम हाइड्रोक्साइड वीक बेस, सल्फ्यूरिक एसिड स्ट्रॉन्ग एसिड, उसमें तो कोई है ही नहीं, सोचने की जरूरत ही नहीं है। HCN तो बेटा वीक एसिड है, वो थोड़ी सॉल्ट है, NaCN बोल, ठीक है ना। ओके, तो वीक एसिड और स्ट्रॉन्ग बेस, तो वीक एसिड स्ट्रॉन्ग बेस के बहुत सारे एग्जांपल हैं, जैसे एक इसने अभी बोला NaCN। इवन अगर मैं सोडियम एसिटेट लूं वो भी इवन NaNO2 है ना, तो ये ले लेते हैं चलो, तो क्या बनेगा NaOH प्लस HCl। अब NaOH क्या है स्ट्रॉन्ग बेस, और ये
वीक एसिड।
कैसा सॉल्ट होगा, सोल्यूशन कैसा होगा
बेसिक
बेसिक होगा। अगर बेसिक होगा तो पीएच क्या हो गई
मोर देन 7।
ग्रेटर देन 7। बताओ कौन सा पार्ट हाइड्रोलाइज हुआ है, कैटायनिक या एनायनिक? गधो एनायनिक, एनायनिक, ठीक है बेटा। कैटायन तो स्ट्रॉन्ग है, स्ट्रॉन्ग है ना, और एनायन जो है वो वीक है, तो वो हाइड्रोलाइज नहीं हो, वो जो है वो डिसोसिएट नहीं होगा, तो इंटरेक्ट कर गया ना वो, तो वीक एसिड जो है वो बना ना, किसकी वजह से बना एनायन की वजह से, तो इट इज एन एग्जांपल ऑफ एनायनिक हाइड्रोलाइसिस। अब बताओ KH क्या हो जाएगा इसका, उसका क्या था KW और KB, क्यों? क्योंकि वीक बेस बन रहा था, अब क्या बन रहा है वीक
एसिड,
तो ये Ka हो जाएगा, ये वैसा ही रहेगा, ये क्या हो जाएगा Ka। यहाँ 7 वहां माइनस था, यहाँ क्या हो जाएगा प्लस, और ये क्या हो जाएगा A। तो वो आ गया, तो ये भी आ गया आपको, समझे? आपको pKa दिया होगा, कॉन्सेंट्रेशन दी होगी सॉल्ट की, निकाल लो pH, कर लोगे। और लास्ट है सॉल्ट ऑफ वीक एसिड एंड वीक बेस, ठीक है, दोनों वीक। जैसे मैं लूं अमोनियम एसीटेट, अमोनियम एसीटेट ले लिया, तो अमोनियम एसीटेट को पानी में डालोगे तो क्या बनेगा एसिटिक एसिड एंड अमोनियम
हाइड्रोक्साइड।
तो ये क्या है वीक एसिड और ये वीक। इसका मतलब अब कैटायन भी हाइड्रोलाइज हो गया, एनायन भी। तो जो पीएच है इसकी, इट इज नियरली न्यूट्रल, इट इज नॉट न्यूट्रल, ठीक है ना। बिल्कुल न्यूट्रल कब होगा, ये अब न्यूट्रल भी हो सकता है और वीकली बेसिक भी हो सकता है और वीकली एसिडिक भी हो सकता है, डिपेंडिंग अपॉन स्ट्रेंथ। अगर रिलेटिव स्ट्रेंथ देखी जाएगी, अगर एसिड थोड़ा स्ट्रॉन्ग है बेस से तो क्या होगा, एसिडिक। अगर बेस थोड़ा स्ट्रॉन्ग है तो बेसिक, और दोनों अगर इक्वल स्ट्रेंथ के हैं तो न्यूट्रल। समझे? अब बताओ इसमें KH क्या हो जाएगा? वेरी गुड, KH इक्वल टू KW डिवाइडेड बाई KA इंटू KB। समझे ना? क्योंकि अब दोनों है इसमें, ठीक है। और इसमें जो है, जो डिग्री ऑफ हाइड्रोलिसिस जो है, ठीक है, डिग्री ऑफ हाइड्रोलिसिस वो हो जाएगा अंडर रूट KH। अब देखो C नहीं आया इसमें कॉन्सेंट्रेशन नहीं आती, मतलब कॉन्सेंट्रेशन जो सॉल्ट की होगी दैट डजंट प्ले एनी रोल, ठीक है। और क्या हो जाएगा H, स्क्वायर रूट ऑफ KW डिवाइड बाई KA इंटू KB, ठीक है। और इसमें pH क्या हो जाएगा, 7 प्लस हाफ pKa माइनस pKb। पता ना, pKa के केस में प्लस कर रहे थे और pKb के केस में माइनस, कॉन्सेंट्रेशन तो आई नहीं इसमें, तो ये हो जाएगा अपने। अब pKa की वैल्यू दियो, pKb की वैल्यू दियो, तो वी कैन कैलकुलेट pH, ठीक है। इसमें कॉन्सेंट्रेशन हैज नो रोल टू प्ले व्हाइल डिसाइडिंग pH, ठीक है। ओके, अब ये तो हो गए अपने। अब देखो इस केस में अगर मैं लिखूं कि pKa इज इक्वल टू pKb, इफ pKa इक्वल टू pKb, तो pH क्या हो जाएगी, 7। और if pKa is greater than pKb, then pH is greater than 7। और अगर pKa is less than pKb, then pH is less than 7। तो न्यूट्रल, बेसिक, एसिडिक तीनों बन सकते हैं ना, डिपेंड करता है सॉल्ट, है ना, स्ट्रेंथ्स। ओके, थैंक यू वेरी मच for watching this video, and in next part we will continue with the same for amphiprotic anion and amphiprotic cations।
जैसे वो आपने बताया ना कि स्ट्रॉन्ग एसिड वीक बेस, तो कैटायन या एनायन जो हाइड्रोलाइज होता है तो उनमें कौन सा होगा, वो कैसे पता करेंगे?
देखो जैसे मैंने लिखा NaCN लिखा था,
हाँ,
NaCN को मैंने वाटर में डाला, क्या बना,
स्ट्रॉन्ग बेस।
NaOH
हाँ,
और HCN।
हाँ,
मैंने बोला जो हाइड्रोलाइज होता है ना, वो कौन सा होता है, वीक,
ठीक है,
वीक एसिड या वीक
बेस।
बेस। अब इनमें से ये तो स्ट्रॉन्ग बेस है, तो स्ट्रॉन्ग तो हाइड्रोलाइज नहीं होगा, इसका मतलब सॉल्ट का Na प्लस इज नॉट हाइड्रोलाइज्ड।
हाँ,
तो इसका मतलब जो Cn नेगेटिव है उसने क्या बनाया,
HCl,
वीक एसिड,
weak acid।
तो इसका मतलब साइनाइड आयन इज हाइड्रोलाइज्ड,
हाइड्रोलाइज्ड,
ठीक है। अब मैं लिखूं सोडियम एसीटेट
हाँ,
और इसको पानी में डाल दिया, क्या बना, एसिटिक एसिड एंड NaOH।
हाँ,
अगेन ये स्ट्रॉन्ग बेस
हाँ,
और ये वीक,
HCl,
तो इसका मतलब जो एसीटेट आयन है उसने बनाया ना वीक,
हाँ,
तो ये हाइड्रोलाइज हुआ और ये हाइड्रोलाइज नहीं हुआ।
इस केस में ये बोलेंगे मतलब एनायन हुआ,
एनायन इज हाइड्रोलाइज्ड, एनायन इज हाइड्रोलाइज्ड। अगर मैं लिखता अमोनियम क्लोराइड,
हाँ, तो
अमोनियम क्लोराइड को पानी में डाला, क्या बना, अमोनियम हाइड्रोक्साइड प्लस HCl, ये तो स्ट्रॉन्ग एसिड है,
हाँ,
और ये क्या बना,
वीक बेस, कैटायन।
तो इसका मतलब इसमें जो NH4 प्लस है उसने बनाया ना वीक बेस,
हाँ,
तो NH4 प्लस हाइड्रोलाइज हुआ
हाँ,
और Cl नेगेटिव हाइड्रोलाइज नहीं हुआ,
नहीं हुआ।
ये हाइड्रेटेड हो गया, हाइड्रेटेड और हाइड्रोलाइज्ड, क्योंकि एक्वा सोल्यूशन बन गया ना इसका, तो ये होगा हाइड्रेटेड और ये
हाइड्रोलाइज्ड।
हाइड्रोलाइज्ड। तो ये कैटायनिक हाइड्रोलिसिस हुई
हाँ
और ये दोनों क्या हुए?
एनायनिक।
एनायनिक हाइड्रोलिसिस।
हाँ
दैट्स इट।
थैंक यू सर।
ठीक है, थैंक यू and do subscribe, like and share my channel and press the bell icon so that you will get notification of my next video. Welcome back students. These are some questions from previous years. Calculate the pH of an aqueous solution of 1 molar ammonium formate assuming complete dissociation. pKa of formic acid is given, pKb of ammonia is also given. अब देखो सबसे पहले आपको क्या देखना था कि ये किस टाइप का सॉल्ट है, वहीं पे क्वेश्चन ओवर हो जाता है। और वैसे भी अगर आपको मान लिया नहीं पता है और आपको pKa भी दिया हो और pKb भी दिया हो तो समझ लो कि वो सॉल्ट है वीक एसिड और वीक बेस का। वैसे ये है ही, क्योंकि आपको मैंने पिछले वीडियो में बताया कि अमोनियम हाइड्रोक्साइड क्या होता है? वीक बेस।
वीक बेस।
और फॉर्मिक एसिड बनेगा इसका।
हाँ।
और फॉर्मिक एसिड आपको पता ही है ऑर्गेनिक एसिड है, और ऑर्गेनिक एसिड सारे क्या होते हैं?
वीक
वीक होते हैं। ठीक है ना? तो अपने पास जो फॉर्मूला बनता है फॉर वीक एसिड एंड वीक बेस, उन सॉल्ट्स के लिए फॉर्मूला याद है आपको?
7 plus half of
7
pKa minus pKb.
प्लस हाफ pKa माइनस
Minus
pKb। और ये फॉर्मूला एनसीईआरटी ने भी दिया हुआ है, इसलिए इस पे क्वेश्चन एक्सपेक्टेड है। ठीक है ना? तो 7 प्लस हाफ और pKa कितना है?
3.8
3.8 माइनस
4.8
4.8। तो 3.8 में से 4.8 माइनस करोगे कितना रहेगा बेटा?
-1.
शाबाश, -1। तो 7 माइनस 0.5 दैट मीन्स
6.5।
तो ये आपका आंसर है। ठीक है, मैंने इतनी देर में किया है, आप ये क्वेश्चन ज्यादा से ज्यादा 15 सेकेंड्स का क्वेश्चन है। ठीक है,
हाँ।
नेक्स्ट क्वेश्चन, आयोनाइजेशन कांस्टेंट ऑफ अमोनियम हाइड्रोक्साइड इट इज गिवन। अब देखो अमोनियम हाइड्रोक्साइड क्या है?
Strong acid weak base.
अभी
Sorry, weak acid, strong acid weak base.
अमोनियम हाइड्रोक्साइड
हाँ, weak base है,
इज अ
weak
वीक
base है।
बेस। अब मेरे से सुनोगे कुछ? वीक बेस और इसका वैल्यू दिया है ये, तो क्या हुआ ये Ka है कि Kb है? ये क्या है? Kb। तो जो आता है उसको जोर से बोलो। ठीक है, ये Kb है एट 298 केल्विन। ठीक है, और ये ऊपर वाला समझ आ गया आपको?
Yes sir।
अब इसके लिए आपको पता है वीक बेस है और हाइड्रोलिसिस कांस्टेंट इसका निकालना है अमोनियम क्लोराइड। तो अब आपके दिमाग में सॉल्ट घूमना चाहिए। ये कैसा सॉल्ट है? ये इट इज सॉल्ट ऑफ
वीक बेस स्ट्रॉन्ग एसिड।
वीक बेस स्ट्रॉन्ग एसिड।
बेस एंड
Strong
स्ट्रॉन्ग
acid.
एसिड। ठीक है,
हाँ।
तो इसके लिए आपको पता है ना KH क्या होता है? KH इक्वल टू
Root of KW of
KW ओवर
KB.
KB।
हाँ।
ठीक है, जो वीक होता है वो नीचे आता है, दोनों वीक होते हैं तो K इंटू KB हो जाता है,
हाँ.
क्योंकि KB दिया हुआ आपको और KW कितना होता है?
-4।
10⁻14।
हाँ।
क्या होता है KW?
Ionic product of water.
आयनिक प्रोडक्ट ऑफ वाटर। अच्छा, तो KB आ गया अपने पास 1.77 इंटू 10⁻⁵। ठीक है, तो इसको आप क्या लिख दोगे? 10/1.77 इंटू क्या हो जाएगा? ये 10⁻15 हो गया फिर, तो 10⁻10। ठीक है, इसके जो ऑप्शंस थे, ये ऑप्शंस बताना इसकी, तो आपको कैलकुलेशन ही नहीं करनी पड़ेगी अगर ऑप्शंस आपको पता हो तो, है ना? बट कुल मिला के कितना हो जाएगा? 10/1.77 5.64 इंटू 10⁻10। दैट्स इट। ठीक है, समझ गए ये भी? ओके, नेक्स्ट क्वेश्चन है, इक्विमोलर सोल्यूशन है। देखो ये सारे आयन दिए हुए हैं, सारे सॉल्ट सॉरी, और पूछा है कि हाईएस्ट पीएच किसकी होगी। तो देखो एक है BaCl2, BA देखो Cl 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 Cl, HCl बनेगा सब में, वो तो निगलेक्ट कर दो। बचा क्या? एक बेरियम है, एक एल्यूमिनियम है, एक लिथियम है और एक बेरिलियम। ठीक है, एक बेरियम क्या बनाएगा? बेरियम हाइड्रोक्साइड। एल्यूमिनियम क्या बनाएगा? एल्यूमिनियम AlOH थ्राइस, एल्यूमिनियम हाइड्रोक्साइड। और लिथियम क्या बनाएगा? लिथियम हाइड्रोक्साइड। और बेरिलियम क्या बनाएगा? बेरिलियम हाइड्रोक्साइड। अब देखो, ये तो वैसे ही ये दोनों एम्फोटेरिक है, ये दोनों हो गए एम्फोटेरिक। और लिथियम हाइड्रोक्साइड भी क्या है? लिथियम इज वेरी स्मॉल इन साइज, हाई पोलराइजिंग पावर, तो ये भी वीक होगा। बट बेरियम जो है नीचे होता है, लार्ज इन साइज। ठीक है ना, तो बेरियम हाइड्रोक्साइड जो है इनमें से स्ट्रॉन्गेस्ट बेस होगा। तो स्ट्रॉन्गेस्ट जो बेस होगा उसकी पीएच हाई होगी। ठीक है, तो इसलिए जो बेरियम क्लोराइड है दैट हैज हाईएस्ट पीएच। ठीक है, और क्वेश्चन?
सर इसमें क्राइटेरिया क्या होता है सर और डिसाइड करने के लिए?
क्राइटेरिया ये है कि जैसे आपने ये लिए है ना, तो इसमें आपको पता है कि एक बनेगा स्ट्रॉन्ग बेस, एक बनेगा वीक, ये एसिड HCl और एक बेस। जैसे आपने बेरियम क्लोराइड लिया, तो बेरियम क्लोराइड पानी में डालोगे तो क्या बनेगा? बेरियम हाइड्रोक्साइड और HCl, ये बना लो। एल्यूमिनियम हाइड्रोक्साइड, एल्यूमिनियम क्लोराइड को पानी में डालो, क्या बनेगा? एल्यूमिनियम हाइड्रोक्साइड और HCl। लिथियम क्लोराइड को तो क्या बनेगा? लिथियम हाइड्रोक्साइड प्लस HCl। और बेरिलियम क्लोराइड को पानी में डालो, क्या बनेगा? वहां ये सोचने नहीं लगना है कि इनसॉल्युबल होगा कि सॉल्युबल होगा, उससे कोई मतलब नहीं है आपको। आपको पता है कि जो कैटायन है वो बेस बनाएगा, एनायन एसिड, वो बना दिए अपने सारे। इनमें से ये सारे तो कॉमन है। ये क्या है? स्ट्रॉन्ग एसिड। तो ये तो अलग हो गया। अब हमें देखना है कि पीएच किसकी हाईएस्ट है ना? तो ये सारे सोल्यूशन जो एसिडिक है, सारे सोल्यूशन एसिडिक है, इसका मतलब पीएच तो लेस देन 7 है ना? बट उनमें से पीएच क्लोज टू 7 कौन सी है, वो देखना था हमें। क्लोज टू 7। अब क्लोज टू 7 किसकी होगी? अगर दोनों स्ट्रॉन्ग हो तो पीएच 7 हो जाएगी। अब देखो, ये स्ट्रॉन्ग एसिड, ये स्ट्रॉन्ग बेस, पीएच 7 होगी। अब ये स्ट्रॉन्ग एसिड बट ये वीक बेस, इसकी पीएच हो गई 7, इसकी पीएच क्या होगी? लेस देन 7। ये स्ट्रॉन्ग एसिड बट ये वीक बेस, इसकी पीएच भी क्या होगी? बेरिलियम, ये क्या है? ये भी वीक बेस, इसकी पीएच भी क्या होगी? तो एक ही बचा जिसकी हाईएस्ट पीएच होगी। ठीक है, जैसे एक और क्वेश्चन था, बताना कौन सा था वो? KCl।
सर KCl NaCl सोडियम बाइकार्बोनेट,
KCl NaCl
सोडियम बाइकार्बोनेट,
सोडियम बाइकार्बोनेट,
Na2CO3,
सोडियम कार्बोनेट बना दो,
कार्बोनेट होगा,
सोडियम कार्बोनेट और
कॉपर सल्फेट।
कॉपर सल्फेट। अब ये दिए हुए हैं और उसमें पूछा है कि हाईएस्ट पीएच किसकी होगी। तो आपको पता है कि KCl क्या देगा? KOH और HCl। ये स्ट्रॉन्ग बेस, ये स्ट्रॉन्ग एसिड। क्या हो गया पीएच? 7। इट कैन नॉट बी हाइड्रोलाइज्ड। इधर NaOH प्लस HCl, अगेन स्ट्रॉन्ग बेस, इसकी पीएच कितनी होगी? 7। इट डजंट मैटर कि K या Na है, क्योंकि स्ट्रॉन्ग बना रहे हैं तो पीएच 7। इधर आ जाओ, बोलो क्या बनाएगा? NaOH
H2CO3
अब नंबर भी नहीं देखने हैं कि ज्यादा बन रहा है या कम बन रहे हैं, सिर्फ ये देखना है कि ये है स्ट्रॉन्ग बेस और ये क्या है?
वीक एसिड
तो कैसा सोल्यूशन होगा ये?
Greater than 7.
बेसिक। और पीएच क्या हो जाएगी?
Greater than 7.
ग्रेटर देन 7।
हाँ
अब कॉपर सल्फेट मैंने दिया था एग्जांपल पीछे ही,
हाँ,
कॉपर सल्फेट।
हाँ,
तो कॉपर क्या बनाएगा? CuOH ट्वाइस।
हाँ,
और ये क्या बनाएगा?
H2SO.
H2SO4।
Strong acid.
ये क्या होगा?
Weak base.
वीक बेस।
Strong acid.
तो कैसा सोल्यूशन होगा?
Acidic.
एसिडिक
एसिडिक मींस पीएच इज
Less than 7.
लेस देन 7
तो
Na2CO3.
ऑब्वियसली सबसे ज्यादा पीएच किसकी होगी?
Na2CO3.
Na2CO3। ठीक है,
यस
कर लोगे?
यस
Okay, thank you very much for watching this video. Do like, subscribe and share my channel and press the bell icon so that you will get notification of my next video. Thank you. Welcome friends, I am Dr. Suresh Thakur, your friend, mentor and tutor for chemistry. Today we are going to learn buffer solution. So buffer solution, it is a solution which resists the change in its pH when we add a small amount of acid or base or on dilution. Types of buffer solution. It is of two types. First is simple buffer. These are salts of weak acid and weak base. For example, ammonium acetate, ammonium carbonate. Second is mixed buffer. Mixed buffer is of two types. It is subclassified into two types. It is either acidic buffer and basic buffer. Now, acidic buffers, they contain equimolar quantities of weak acid and its salt with strong base. For example, acetic acid and sodium acetate, or boric acid, sodium borate, phosphoric acid, sodium phosphate, formic acid, sodium formate. These are the examples of acidic buffer. Now, basic buffer. Basic buffers, just like acidic buffers. Acidic buffers contain equimolar quantities of weak acid and its salt with strong base. So you can get an idea what about basic buffers. They contain, yes, equimolar quantities of weak, yes, as acidic buffer contains weak acid, basic buffers contain weak base and its salt with strong acid. For example, ammonium hydroxide and ammonium chloride, or ammonium hydroxide and ammonium nitrate. So these are types of acidic buffer, basic buffer. In acidic buffer, pH ranges from 4 to 7, and for basic buffers, pH ranges from 7 to 10. Even, please note this point, that even strong acids or strong base can act as a buffer, because if you take strong acid, like let us take example, you take 100 ml of 0.1 molar nitric acid. Now in this solution, if you add 1 ml of 0.1 molar HCl, does it make any difference in its pH? No, because you have a strong acid 100 ml and then you add another strong acid only 1 ml, that doesn't make any difference in its pH. So strong acid or strong base can act as a buffer solution. These are the types of buffer solution. In my next video, I will explain the buffer action of acidic buffers and basic buffers. Welcome back, friends. I am Dr. Suresh Thakur, your friend, mentor and tutor for chemistry. Today we will learn Henderson equation. Henderson equation is used to calculate pH of buffer solution. Let us derive Henderson equation for acidic buffer. In acidic buffer, we have weak acid and its salt with strong base. Now you know, weak acid ionized feebly, ionized to lesser extent, and salt will be an A negative aqueous. And due to the presence of common ion, this is common ion effect, equilibrium shifts backward, and as equilibrium shifts backward, dissociation of weak acid is suppressed. That means weaker acid becomes more weaker. Means acidic strength of base further decreases. Already it is a weak base, it becomes weakest due to the presence of its salt. That means A negative ion contribution from weak acid is very less as compared to A negative ion obtained from its salt. That's why A negative from weak acid, contribution of A negative from weak acid is neglected as compared to A negative ion obtained from strong electrolyte. And dissociation of weak acid is too less. It cannot be counted quantitatively. So this is a weak acid. So what is Ka for weak acid? So dissociation constant of acid is H3O plus ion concentration, A negative ion concentration divided by HA concentration. And from this, H3O plus ion concentration is equal to Ka into HA divided by A negative. Now this HA is equal to initial concentration of HA minus concentration of HA gets dissociated. But dissociation is too less to be counted, therefore that can be neglected, and HA concentration is considered as initial concentration of weak acid. Keep in mind, this is actually initial concentration of HA minus concentration of HA gets dissociated, but that is too less to be counted. Therefore, we take it as initial concentration of HA, and A negative is equal to, because it is a strong electrolyte, whole Ba is converted into B positive, and A negative, the initial concentration of BA plus concentration of HA undergoing dissociation, but that is too less, that cannot be counted, and therefore A negative is initial concentration of the salt. So we can write this equation as Ka into acid concentration divided by salt concentration. So pH is equal to minus log of HCO plus, that is equal to minus log of Ka into acid concentration to the salt concentration. So it is equal to minus log of Ka minus log of acid by salt. And what is minus log of Ka? We have already done it. pKa plus log, if we use plus sign, it is reciprocal of acid by base. So reciprocal of acid by base is salt by acid. So it means pH equal to pKa plus log of salt by acid. This is Henderson equation for acidic buffer. Now if salt to acid concentration is 10, so log 10 is 1. If salt concentration to acid concentration is equal to 10, then pH is equal to pKa plus log 10. And what is log 10? 1. So pH equal to pKa plus 1. And if salt by acid is equal to 1 by 10, then pH equal to pKa plus log 1 by 10. Log 1 by 10 means log 10 raised to power minus 1 minus 1 log 10. So it becomes pKa minus 1. So we choose weak acid in such a way that its pH is between pKa plus 1 to pKa minus 1. We choose weak acid so that pH of buffer solution is between pKa plus 1 to pKa minus 1. For basic buffer, it is a mixture of weak base and its salt. BOH is a weak base, it ionizes like this, and BA is a strong electrolyte, it gives B positive and A negative, and due to the common ion, equilibrium shifts backward. So basic nature of weak base is further reduced. So it is feebly ionized, very less ionization of BOH takes place. B plus and OH negative ion obtained are very less, and this B plus ion is neglected as compared to B plus ion obtained from the strong electrolyte, that is a salt, that is from the salt. Now dissociation constant of the base Kb is equal to B plus ion concentration into OH negative ion concentration divided by BOH concentration. That implies OH negative ion concentration is equal to Kb into BOH divided by B plus. Now this BOH is equal to initial concentration of weak base minus concentration of BOH undergoing dissociation, but concentration of BOH undergoing dissociation is very less, so it is considered as initial concentration of BOH. B positive is equal to initial concentration of Ba, that is salt, plus concentration of BOH undergoing dissociation, that is very less, is neglected. So this becomes concentration of the salt, and this is the concentration of base. So in this way, OH negative ion is equal to Kb into base concentration to the salt concentration. Now as we have OH negative ion, so we can calculate POH. What is POH? Minus log of OH negative, that is minus log of Kb into base concentration to the salt concentration. So POH is equal to minus log of Kb minus log of base to the salt. That implies POH equal to, what is this? PKB. To make it positive, it become reciprocal. So log of salt by base. So POH equal to PKB plus log salt over base. From minus log of base to salt to plus log of salt to base. If you didn't understand, then it is, say, log of base by salt, that is equal to log of base by salt raised to power minus 1, because minus 1 is multiplied by it becomes power of this law of logarithm. So it becomes log of salt over base minus plus, minus log of base over salt plus log of salt over base. So this is second Henderson equation. pH equal to pKa plus log salt over acid for acidic buffer. POH equal to pKb plus log salt over base for basic buffer. And to calculate pH, you know pH plus POH equal to 14. So pH equal to 14 minus POH. That's all for Henderson's equation. Buffer capacity. Buffer capacity is the property of a solution to resist change in its pH value. That is called buffer capacity. And it has been found that if ratio of the salt to acid or salt to base concentration is unity, pH of buffer solution does not change at all. That means such a buffer solution is efficient. Such a buffer solution is known as efficient buffer solution, and in that case for acidic buffer pH is equal to pKa, for basic buffer pOH equal to pKb. And to calculate buffer capacity quantitatively, it is denoted by sign phi. It is equal to number of moles of acid or base added in 1 liter of solution, in 1 liter of buffer solution, divided by change in pH. That is number of moles of acid or base added in 1 liter of buffer solution to the change in pH. In this way we calculate buffer capacity, and buffer capacity is maximum only when salt concentration is equal to acid concentration, or salt concentration is equal to base concentration for acidic and basic buffers respectively. Thank you very much for watching this video. If you like this video, do press thumbs up button. If you still haven't subscribed my channel, do subscribe it now. Press the bell icon so that you will get notification of my next video. God bless you all. Happy learning. Now buffer action of a buffer solution. So buffer action is ability of buffer solution to resist change in its pH on addition of small amount of acid or base to it. So what is buffer action? It is ability of buffer solution to resist change in its pH on addition of small amount of acid or base to it. Let us discuss the buffer action of acidic buffer. Let's take an example of acidic buffer of acetic acid and sodium acetate. So you know acetic acid is a weak acid. So weak acid dissociates to some extent. So ionized form and unionized form, they are in equilibrium. Sodium acetate is a strong electrolyte. It dissociates completely to give acetate ion and Na plus ion. Now see, there is a common ion, and you know when there is a common ion at equilibrium shifts backward. So dissociation of weak acid is suppressed because of the presence of common ion. That is called common ion effect. Case 1. Add acid. Now we add acid in the acidic buffer. When we add acid, say HCl, when we add HCl, you know HCl is a strong acid. It gives H3O plus ion. So initially due to the addition of HCl, there is an increase in H3O plus ion. So there should be decrease in pH, because pH is minus log of H plus ions. Now, these H3O plus ion, when get into the solution, they react with already present acetate ions, and we get acetic acid and H2O. So you know that H2O is a weak electrolyte, acetic acid is a weak acid, so it doesn't change pH of the solution, because H3O plus ion added by the acid gets neutralized by the base present in the buffer solution. So acetate ion act as a base for the acid added, and that's why there is no effect of adding small amount of acid in the buffer solution. Case 2. If we add base, when we add base, say NaOH, when we add NaOH, you know, NaOH again, it is a strong, now base, it gives Na plus ion and OH negative ion. So OH negative ion makes the solution more basic, means pH should increase due to the presence of OH negative ion. But when OH negative ions are added, H3O plus is in action, and H3O plus ion already present in the buffer solution react with OH negative ions and give H2O liquid. In this way, we add H plus ions or OH negative ion, buffer solution neutralize it. If we add base, acid present in the solution act against it. If we add acid, base present in the solution act against it. That means buffer solution has reserve acidity as well as basicity, which counter attack on the acid or base if we add them in the buffer solution. And in this way, buffer solution resists the change in its pH. So this is the buffer action for the acidic buffer. Now let us take example of basic buffer. Buffer action of basic buffer. Basic buffer, for example, ammonium hydroxide plus ammonium chloride. So, you know, ammonium hydroxide is a weak base. It gives NH4 plus and OH negative ions. NH4Cl is a strong electrolyte. It gives NH4 plus and Cl negative ions. Again there is a common ion, and due to common ion effect, dissociation of weak base is suppressed. Again, example of common ion effect. Now case 1. When we add acid, for example HCl. So HCl is a strong acid. It gives H3O plus and Cl negative. HCl gives H plus ion to the solution. H3O plus ion increases in the solution, so pH should decrease. But as H3O plus ions are added, OH negative ion present in the buffer solution react with it, means neutralize the effect of H3O plus, means acid, when we add base present in the solution neutralize it, and therefore pH of the buffer solution will not change. Now case 2, when we add base, like NaOH, it gives Na plus ion and OH negative ions. When OH negative ions increases in the solution, pH of the solution should increase. But when we add OH negative ion, NH4 plus ions present in the solution react with OH negative ions and we get NH4 OH. Equilibrium shifts backward, and in this way effect of adding OH negative ion gets neutralized. So in this way we add acid or we add base, their effect is counterbalanced, their effect is neutralized because of the reserve acidity or reserve basicity of the buffer solution. OH negative ion is the reserve basicity of the buffer solution, and NH4 plus ion is the reserve acidity of the solution. A buffer has a reserve acidity which it uses against a base. It has reserve basicity which it uses against an acid. So in this way you came to know the buffer action of acidic buffer as well as basic buffer. Thank you very much for watching this video. If you like this video, do press thumbs up button, share my channel with your friends. God bless you all. Happy learning. Om Shanti. Good evening students. Today we will study solubility product and its See, solubility means maximum amount of solute that can be dissolved in a particular amount of solvent. Clear? So for example, we have NaCl. If we dissolve NaCl solid in water, what would happen? It turns into Na plus
CL
and Cl negative. Clear? So it is like Na plus aqueous plus Cl negative aqueous. Because NaCl, when dissolved in water, it turns into ions, Na plus ion and Cl negative. Now if we go on adding NaCl, so what happened? After some time, NaCl
will stop dissolving.
will stop dissolving. It cannot dissolve. Clear? So that means that is the saturation point. So now at saturation point, what would happen? If we add more NaCl, it gets dissolved and equivalent amount of Na plus and Cl negative ion from the solution, it
Will combine.
combine to form NaCl solid. So now this forward term, it become equilibrium. Yeah. Now NaCl solid is in equilibrium with Na plus aqueous and Cl negative aqueous. Clear? Now at that time, that is called saturation point. So at saturation point, product of the concentration of ions is called solubility product. In this case, number of mole is 1 and 1, so its power is 1. Otherwise, if take an example of CaCl2. Now, if we have CaCl2, then at saturation point, calcium 2 plus aqueous and 2 Cl negative aqueous. They are in equilibrium with CaCl2 solid. So now, what is KSP? Concentration of calcium 2 plus ions into
Concentration of Cl negative ion to the power 2.
raised to power 2. Clear? So, it is defined as product of the concentration of the ions of an electrolyte raised to the power their coefficients in the balanced equation. Clear? And that is called solubility product. And this solubility product is constant at constant temperature. Clear? Now, if before equilibrium, if we take it, the product of ions Na plus ion and Cl negative ion, except at equilibrium, so that is called ionic product. And at saturation point, that ionic product becomes equal to
Saturation.
solubility product.
Solubility product.
Got it? Ionic product at any time, clear? And at saturation point, or we can say saturated solution, the product of the concentration of ions is called
Solubility.
solubility product. Clear? In this way, we can predict that in a particular reaction, when the precipitates are formed. Clear? So first application of solubility product is to predict the formation of precipitates. Case 1. If ionic product what is ionic product? Again, same product of the concentration of the ions at any point. Clear? If ionic product is less than solubility product, then no precipitate is formed. In case 2, if ionic product is greater than solubility product, then precipitation takes place. Then precipitate is formed. Clear? Now, this is first application. Second application is we can predict the solubility of a sparingly soluble salt. Sparingly means partially soluble salt. So second application is to predict solubility of partially soluble salt. Take take an example. For example, if we have Al2SO4 thrice, solid Al2SO4 thrice, when we dissolve it in water at saturation point, it is in equilibrium with its ions. Al3 plus ion. How many Al3 plus ion? 2. And SO4, 2 negative ions. How many?
3.
3. Good. Clear? Let us take an example. The solubility is S. Capital S is solubility of this salt, this electrolyte. Clear? So if S is solubility of this particular electrolyte, then how many aluminium 3 plus ions are there? 2 times S. Clear? Because S mole per liter of Al2SO4 thrice is there. So Al3 plus ions are 2 times of S and sulfate ions
3 times.
Good.
Yes.
3 times of S. Right? Now what is KSP? As per our previous discussion, there is Al3 plus ion, concentration of Al3 plus ion raised to power
2.
2. Good. And SO4 2 negative ion raised to power
3.
3. And Al3 plus ions are
2s.
2s. So just write 2s raised to power 2. And sulfate ion
3s.
3s raised to power
3.
3. So what is the value now?
27 into 4s.
27 into 4. That means it is 4s raised to power 2 into
27s to
27s raised to power
3.
3. So 27 into 4. 27 into 4. 108. So it is 108 into s raised to power. Powers are added up. So it is s raised to power 5. 108 into s raised to power 5. So in this way, s is equal to KSP divided by 108 raised to power
1 by 5.
1 by 5. That means if we know solubility product of the salt, of the electrolyte, we can calculate solubility of the electrolyte. Clear? So it is another application of the solubility product. Third application is salting out of soap. What are soaps? It is what is soap? Sodium or potassium salts of higher fatty acids, right? And you know soaps are least soluble. Clear? So these are sodium or potassium salts of higher fatty acids. R is an alkyl group, large chain of carbon atoms. Okay, so it is in equilibrium with RCO negative and Na plus, right? Now these ions are in equilibrium with RCO Na. To make salt again, or to reverse this reaction, we can use another effect that is called common ion effect.
Okay.
So what is common ion effect? If we add an ion common to the salt, like NaCl, if we add NaCl, clear, to small amount in water, you know NaCl is completely soluble in water. We are not talking about we make saturated solution of NaCl. We are just adding a small amount of NaCl.
Okay.
As we add NaCl, what would we get?
Na plus
Cl
Cl
negative.
negative.
So Cl negative ion and Na plus ion added in the solution. So now this Na plus, these are common ions. Clear?
Yes, sir.
So what is ionic product of this salt, this soap? This is ionic product is equal to
Concentration of Rc.
this carbonate ion and
Concentration of Na plus.
Na plus ion. Clear? So now as we add NaCl, we are increasing Na plus ion, and when Na plus ion is increased, what would happen? This ionic product increases, and ionic product, when this ionic product is greater than solubility product, what happens?
Precipitation.
Very good. Precipitation takes place. So precipitate is formed, and precipitate means this formation of this soap. So that is called salting out of
So
precipitate is formed. So in this way we can prepare soap. Clear? And last application is purification of NaCl. Clear? NaCl, again, NaCl is soluble in water. Now we prepare saturated solution of NaCl. First we dissolve NaCl in water. Clear? So we get Na plus ion, Cl negative ion, along with other impurities and insoluble impurities. So first we filter out insoluble impurities. Now we left with soluble impurities as well as saturated solution of NaCl, because NaCl is in maximum amount. So saturated solution of NaCl is formed. Only saturated solution of NaCl is formed. Now we pass HCl through it. And when HCl is passed through water, HCl is a strong acid in water. So HCl gives H plus ions and Cl negative ion. Again there is a common ion effect. This is common ion. Actually here we apply Le Chatelier's principle. According to Le Chatelier's principle, what would happen if we increase one of the product? Equilibrium shifts
backward.
Clear? And that is common ion effect. Clear? In this way we can purify NaCl. So pure NaCl is obtained. This is again an application of solubility product. Other applications are in salt analysis that we will discuss later on. Okay, thank you. Any doubt?
Yes, sir. Sir, can we use Le Chatelier's principle in our previous example?
Yes, why not? Because in that case, I forgot to say, otherwise, this is first equilibrium. That was the case. Then we add NaCl in it. It becomes Cl negative aqueous and
Na positive.
Na plus aqueous. There is common ion effect, same case. Clear? Now, as it is a common case and one of the product is increased, so according to Le Chatelier's principle, when one of the product is increased, equilibrium shifts backward. So, same principle applied in both the cases. Okay?